Hello, this is Lori Frary and my co-host Lawrence Wright. And with us today is Thomas Thompson. Thomas has a Facebook group called Flat Earth News, and it is a really good page with very good research on it. So I encourage you, if you are a flat earther or even somebody who's just investigating, to go check that out. I have Flat Earth Conspiracy Advanced Facebook page and a Flat Earth Conspiracy group. And we have the podcasting. You can hear us on iTunes and many of the other MP3 services. Welcome to the channel if you're new to this channel. We had a recent debate that I took part in with Darren Nesbitt and Jaron Campanella and David Weiss. And so we have some new subs because of that. So welcome. And we have been investigating the flat earth for several years. Lawrence the longest, I think me the second, and then Thomas. But collectively it's probably 3 or 4 years total. And so we decided, I decided to start doing some YouTube hangouts, and Lawrence joined me pretty much from the beginning. We've had Thomas on before, so welcome back, Thomas. And our research is based in finding the reality of flat Earth and have moved past what is typically known as the flat Earth map and model, the circle Earth map and model. And the reason why we've moved on is because we have disproved it as observable reality, and we've decided that we're going to go in search of why everybody is still using that and promotes that, but also waiting for the time when more people realize that it is wrong, and that they will join us in further investigation and research into, well, what is it more like, or what is it really? We may find after 10 years or by death that we have never actually discovered what it is, but hopefully we'll get closer than what we were introduced to when we first joined up. So with that said, thanks you guys for joining me, and we're going to do probably a couple hours of discussion this evening, and we will be back tomorrow night to add to the discussion. And hopefully by the end of these two, Part 1 and Part 2 hangouts, we will have an accumulation of enough information for most of you who have actually open minds and critical thinking will understand why we hope that people stop promoting the AE map and model, the Gleason map and model, and anything that has the sun going in a circle and an ice wall around the perimeter, and so on and so on. So, Lawrence, are you with us? I think his camera is off and he is muted. So, Lawrence, if you may have to drop out and come back in because I think we lost you. So, Thomas, let's start out with some of the reasons why you are in the camp of anti-Gleason, anti-AE as the flat Earth map and model, how you arrived at that, and what you're doing along with people like me and Lawrence and many others to try to dissuade people from continuing along that path.
Okay. All right, well, I'll start from the beginning. I discovered flat Earth about 3 years ago. I discovered it through a series of videos by Eric Dubay. And immediately, I was with this model. Eric proved to me that the Earth was indeed flat. He showed me many proofs. So, and I was absolutely convinced at that point that the Earth was flat. Once I did a little bit of research into it, I was convinced, yeah, this guy is right. Well, the thing is when he demonstrated to me the greatest conspiracy of all, that the Earth was flat, he also handed a model to me to go along with it. And this model was already completely solved. It really didn't have any more questions. It told me how the whole system worked. The Earth was flat. It was circular shaped. The sun goes in a circle. The heat can only go so far. So so you get an ice wall on the outer edge, or an ice shore, however you want to call it. The Gleason map, basically.
Mm-hmm.
And at first, I was just mesmerized by this. I'm brand new to flat Earth, and hearing this for the first time and realizing that the Earth is flat. What if Eric would have told me that the sky was pink at that point? I might have even believed it. I mean, I was just willing to believe whatever he said, because this was the greatest mystery ever, and he just uncovered it for me and handed it to me on a silver platter. But the problem came in when I tried to go out and talk to my friends and other people in the public, and I tried to show them my proofs, and they were debunking me left and right. And I would argue with them, and I would say what I heard in the video. I'd repeat exactly what I heard in the video, but these guys were just destroying me, these globe earthers. And I'd go back and I'd check the facts, and sure enough, all these facts that these globe earthers were telling me were proven to be absolutely true. So I started going on a systematic search of the Gleason map, of its various facts, and I just found error after error after error with it. That was about 6 months after I was already into the movement. It took me a good 6 months to realize all the errors, once even today. And so for about the last 2 years, I've been in the camp where I didn't really want to give my map and model a specific name, although I have a preference today. I do like the diamond today. I just knew that the Gleason model of the continents circling around a central North Pole and there not being any South Pole, these were erroneous concepts. They're telling me that Antarctica is not really a continent, it's actually a giant ring. They're telling me I can't go to the ice wall, or I can't go to this ring because it's pretty much manned. 65,000 miles of military patrolling to make sure no one sneaks in, I suppose. It's all supposed to be heavily guarded. And I just came up with problem after problem. And to come up with, okay, you know what, we'll start from the very top. Here's the thing, when you can check your celestial equator with celestial Cancer and Capricorn, you will notice that if you're standing on the equator, that your equator goes perfectly straight. If it's spring or fall, the equator goes perfectly straight. And you'll notice, if you time lapse the stars, that those stars that follow through the Tropic of Cancer bend up to the north, and the stars that follow the Tropic of Capricorn bend down to the south. But on this Gleason map that I'm looking at, that they're telling me is the flat Earth model, it's showing me Cancer, the equator, and Capricorn all going in the same east to west direction. All in the, just except for Cancer's a small circle, and then the equator's a little bit larger circle. And then Capricorn would be the largest outer circle. Well, the problem with this, I discovered right off the beginning, is these are three completely different size circles. This means the sun would have to change travel speed to keep 24-hour days. And now here's how this works. The formula is, no matter what the size of the circle, doesn't matter how high the sun is off the ground, doesn't matter how close it is to the ground, this is the formula. Distance traveled divided by time spent traveling equals the speed of travel. This is not a negotiable formula. This is just how it is. Now, in order for the sun to travel the equator and have a 24-hour day, the sun would have to travel 1,037.5 miles an hour. And when we check timeanddate.com, we see that this is true. However, when it's going to Cancer, and it's going to slow down a slight bit as it goes to Cancer, the circle's even smaller than the equator. This means the sun needs to slow down to a speed of 771 miles an hour so that it can have a 24-hour day there. Because if it keeps going at 1,037 miles an hour like it does in the equator, the day would go by too fast. Whereas when the sun moves into Capricorn, and again, when the sun leaves the equator to go to Capricorn, it actually slows a bit. This gigantic Capricorn ring, the sun would actually have to travel, I wrote it down here, where's it at? 1,322 miles an hour. The sun would actually have to increase the speed up to 1,322 miles an hour in order to travel the entire circuit of Capricorn and still maintain a 24-hour day. And the problem is we can follow the sun all year round. That time and date, you can trace the sun out and you can track it every single second of the day, real time. And we know the sun goes 1,037.5 miles an hour with less than 2% fluctuation in the speed all year round. So already you have a giant problem there. You can't have a circling sun. Not to mention the equator is going straight. Capricorn bends one way, and Cancer bends the other way. Well, that's on the Gleason AE map, all three of them lines bend the exact same way. They've completely removed the South Pole. They said there is no South Pole. And I'm talking to these guys, and I'm like, well, guys, look, if you're going to tell me there's no South Pole in my flat Earth, you do realize that the South Pole has a completely different set of stars than the North Pole. Just like the North Pole all rotate around and form a little circle, tight-knit circle around Polaris. Well, the South Pole, there's not a star in the dead center of the South Pole, but it's just slightly off a little bit, Sigma Octantis. Well, there's an entirely different set of stars at the South Pole that orbit around that in the same way. You know, and I see these guys, they try to show me these examples of inversion and try to explain it away. No, there's no South Pole, it's just a giant ring. And I'm like, well, what about the South Pole Aurora Borealis? It's the Australia Borealis. And they said, well, either that stretches all the way around a 65,000 mile ring, or that doesn't exist either. So if I say there's no South Pole, I have to pretend half of our stars have to be missing. We have to claim the stars are missing. We have to claim there's no magnetic pole. And if you know anything about magnetism, where there's a North Pole, there has to be a South Pole. We don't live on a monopole magnet. As simple as that. If we have a North Pole, we have a South Pole. And if you put the North Pole in the dead center of our map, the South Pole is actually going to be under the map. So how's the compass going to work? You're going to hold a compass up so north points to the sky and south points to the earth? Because that's how a compass would work. If you have, you know, where your entire top is the North Pole, you know, if you live on a disk magnet with the center being the North Pole, then the bottom of the disk is your South Pole. Your compass can't work like that. It's not possible. So I have, you know, an entire list of things we can go over that just utterly destroy this idea that there can't possibly be a circling sun. It has to be going. It does arc in summer and winter, but in fall and spring, the sun we can track it. We can prove it goes perfectly straight on the equinoxes. There's specific days you can, and there's monuments, ancient 1,000-year-old, you know, thousands of year old monuments that demonstrate, that prove the sun's traveling a perfectly straight line. So yeah, one of my problems there was, again, Cancer, the equator, and Capricorn are all three different sizes. When in reality, when I looked it up, I found out that Cancer and Capricorn are the exact same size. They do fluctuate throughout the year because, you know, it's a magnetic field. But basically, it's 18,340 miles is their average length, both of them. Well, how can Cancer and Capricorn both be the exact same length on a Gleason AE projection map? It can't be. And on top of that, Cancer and Capricorn, they're both 18,340 miles. whereas the equator itself is 24,901 miles, meaning the equator is actually larger than both of them. So here again, you have a problem. It just doesn't work out. It can't work out.
Good. Those are very good. And we've come to the same conclusions, haven't we, Lawrence? Lawrence is muted. He's been a good guy. Okay,
You're muted, Lawrence.
There, let me unmute.
Oh, sorry.
There you go.
Yeah. Yeah. I mean, well, can I just throw something into the pot now? And I want to test your observation skills because this is new information. Nobody's brought this one up before. So I'm just going to share a screen with you. And I want you to spot something that you may not have seen before, which is glaringly obvious. Have you gone, Laurie?
No, I just turned my camera off because
Right,
I know
okay,
what
I'm
happens
gonna
when
share a
you
screen.
share the screen. I get popped up there.
I'm going to share a screen.
Okay.
And you, Thomas, you can join in as well. And tell me what you see that is unusual or needs further explanation. So I've just brought up a Gleason map. This is a high definition one that I've downloaded here. Okay. So what I'm going to do, I'm going to
notice how
zoom
they
in.
always tear that. You notice how they always tear them in the dead center. There's actually, you see that little pole that comes off there, that little piece of
Yeah,
paper?
the timekeeping device.
Yeah. Isn't that amazing how they tear them off of every flat Earth map? You never
Yes,
see
they
them
do.
on there.
And that's exactly right. Don't want that to be talked about too much. Okay,
Okay,
go
Then
ahead.
they'll say, "Oh, well, that's
You're
yeah, that's
sharing.
the,
You're sharing. Okay.
Okay, well, let me talk a bit. So the ice wall, if it exists, or as with the shoreline, as they're now saying, they're backtracking off the ice wall, the AE map defenders. They're saying that, you know, the ice wall, if basic trigonometry is correct, it would be 78,000 miles. There is an inherent problem with that, aside from the fact that it doesn't exist. And I'm hoping you can see what I'm seeing. And now I've zoomed in on this. Obviously, the real South Pole, the distance around that is a small fraction of 78,000 miles. I don't know the precise distance, but it's probably more like 10,000 rather than 78,000. But here we are. We're on the ice wall. Can you both of you see it?
Yes,
Yeah.
the small,
The ice wall.
the zoomed in part. Yes, Lawrence.
Okay, so you can see that we've got these little pieces of pie. Each of these represents like an hour going round.
Right.
So we've got 24 of these, and each of these sections on the ice wall would be 3,000 miles. So let's go through them, and you give me your comments as we're going along. Anything that springs to mind, because obviously you can,
wait a minute, hold on.
Yeah.
So first of all, Lawrence, okay, each one of these longitude or latitude lines we're saying is 1 hour.
well, it's
then-
divided into 24 segments, 24
Right, so
pieces
yeah,
of
that has
pie.
to represent.
So if you
Well,
divide
that,
24 into 78, it's just a bit
Right.
over 3,000.
So
So
you're
on the
telling
outer line, that distance would be about 3,000, just over 3,000 miles. Okay,
Yeah,
so
that's-
let's go around, and you too, Laurie. Let's just pan around and tell me what your observations are.
all right, hold on, stop right there, stop. Okay, you're telling me that the sun can travel across the entire length of Australia in only 2.5 hours. That's not possible.
Okay, well that's
It's
another
fine.
observation. Yeah, okay. I wasn't particularly referring to that, but let's carry on. I'm referring specifically to the outer ring, and something that I've noticed about this, which hasn't been pointed out before, and I'm hoping either you or Laurie will identify it without me telling you.
Okay,
So
hold on. Let me make sure what you are considering the outer ring, and for those who are watching on YouTube, are you talking about the broken black and white line or the solid black outer ring line?
Well, the bit from the
Or are
bit
you
from the
talking about the
Antarctic
coastline?
Yeah, from where my cursor is now.
Okay, gotcha.
to-
The coastline.
All right, so I'm just going to
Like
pan
where
around.
it says north,
Yeah,
north
Northland.
right
Right. Okay.
Yeah,
there. Yeah.
all right.
So let him talk.
Let's pan
Let him
around.
talk without interruption. Go ahead, Lawrence.
Let's pan around, and when you spot something unusual, just butt in and say what you think. Now here's a clue. Okay, what do you see there? What do you see in this sector here?
Kind of just a really nice straight coastline.
Yeah.
Yeah, and what else? What else
And
can you
nothing,
observe?
and nothing's there. No,
Nothing's there. Good point, Laurie.
nothing named.
What about this one?
Okay, nothing's there. 3,000 miles. Nothing's
Nothing there for 3,000 miles. Okay, and what about this one here?
Yeah, it's the same way. Yeah.
There's nothing there as well. That's another 3,000 miles where nobody's been there. What about this next one? Oh dear, there's nothing there either.
Yeah, there's like no shape to the whole line. Yeah, I see what you're saying. There's no shape at all.
You know, I mean, what you've got here is because the Antarctic isn't 78,000 miles round, they've had to fill it in with filler, blank spaces. So we've got another blank space of 3,000 miles, and yet another blank space, and yet another blank space.
Yeah, you're absolutely right.
You've got Greenland, Alexanderland. Oh, look, we've got another blank space.
They drew a little bit there.
All right, let me play devil's advocate here just for a second, Lawrence, because I see exactly where you're going, and I see the same thing you see and Thomas sees. When was the Gleason created? The Gleason map.
It was created about 4 years ago, but allegedly it was from 1892. But
allegedly from 1892. So
get back to our earlier hangout. Yeah, we show that the Gleason map is a complete fake, modern day fake.
But let's go to 1892. Okay, but let's go to 1892 and play devil's advocate, because that's what we do. We're very good at opposition research, so we have to think like the opposition would think. And the opposition would say in 1892, nobody had set up any camps or towns or anything on any of these areas yet, because they were in those very hard to travel areas in the South Seas where the currents were horrific and the weather was horrific and so on and so on. These are all excuses that we've heard for why no one has explored any of this land. So, but it is very curious that instead of trying to even kind of fake a little bit of, in and out coastline, it's all just a nice, it's almost like a nice icy beach.
Let me add this into that. Let me add this here. We have over 50 nations. I hear this all the time. We have over 50 nations involved in this Antarctica Treaty. First of all, with over 50 nations, scientists there, you can't tell me they don't know the exact shape of that. If that was a giant ring, can't tell me over 50 nations and no one knows. Oh, let's just paint it one solid straight line all the way down. Come on, that's not even logical.
No, but when you look at modern day maps, you're not finding lots of new places marked on the maps to fill in these gaps. They're not there. There's only the places marked on here anyway. Obviously, apart from the research stations we've talked about. But let's move along a bit further, because there's something.
Can I interrupt, Lawrence? Your sound is breaking up. It's cutting in and out. Are you hearing that also, Thomas?
Yes, I was. Yeah.
Okay. It's either your microphone or you need to jump out and jump back in again. I don't know which one it is.
A short or a wire touch.
Yeah, it sounds like a wire shorting. Okay. So while he's got that up there, I just did the math, and if these are 3,000 across between each of these longitude lines, then that comes out to 72,000 miles around the perimeter. So we're constantly hearing, no, it's only 65,000 miles, and then someone else says it's 78,000 miles, and then this says 72,000 miles. Even if you go with the smallest number of 65,000 miles, three things come to mind. That how are they protecting all of this ice from anyone trying to get on it? And we also know, what is the length of the Ross Ice Shelf? Thomas, you know that.
373 miles.
Okay. And that is the only ice shelf like it that it's ever been talked about in Antarctica.
That's
Okay.
actually, yeah, by the Ross Sea, I believe.
Right.
As a matter of fact, that's a good time to go into a story that you uncovered for me, and that was a story of Ronald
Amundsen.
Yes, Amundsen, born July 16th, 1872, died June 18th, 1928. He was a Norwegian explorer, the very first man to make it to, with a team, of course, make it to the South Pole, and he arrived there on December 14th, 1911. He started at the Ross Sea, and he started at 168 degrees west, 80 degrees south, and he traveled to 90 degrees south, 0 degrees west. Now, I planned on bringing this up anyways, because here's the thing of this, for our listeners. If you have to realize, you see all these little marks on the outside edge of this Gleason map in the red area? Here's the thing. A circle is divided up into 360 degrees. Well, wherever your 0 point is, 180 degrees is always the exact opposite side of the 0, of wherever your 0 point is. Now, here's the thing. These expedition people started at 168 degrees west, 80 degrees south. Well, we already know that halfway across the circle is 180. They started at 168, so that's just a little less than halfway, not quite to the halfway point. Now, they're going to travel all the way down from 168 degrees west, 80 degrees south. They're going to travel all the way down to 90 degrees south and 0 degrees west, which means basically south, they're only going to go 10 degrees closer to the outer rim of this so-called ring. But the problem comes in when they're going to be going 168 degrees west all the way down to 0 west. In other words, they're going to have to travel halfway. They're going to literally have to travel almost half of that distance. Now, we just said that distance, if we give them a break and say it's only 65,000, and you say, well, half of that is only, say, 33,000. But we weren't quite at that 180 degree because they left at 168, so it wasn't quite half. So we'll drop it down to, say, 25,000 miles. That means that expedition would have had to travel 168 degrees west to 0 degrees west is over 25,000 miles. But we know for an absolute fact that the journey was less than 900 because this was a world event. These were the first people going to the South Pole that were going to trek there. This was like world news. People were bored back then. They didn't have much to amuse them. When somebody decided they were going to spend a fortune sending a group of people to the South Pole, everybody in the world paid attention to this. The media was there. Everybody noted this. They traveled less than 900 miles and made it to the South Pole. Well, these coordinates say they traveled 25,000 miles according to this Gleason map. So this ice ring simply cannot exist because this is not the only. People have done the same exact trek hundreds of times throughout history since then. To this very day, you can actually get on your Google, type in Antarctic tours. You can actually get a tour for any length of time you want to go there, pretty much within reason. You can't stay there for like 20 years, but you can go take these exact treks. These treks are less than 1,000 miles, and I've tracked several of them. All of them, less than, at the most, 1,500 miles at the very most. Not one of them was a mile more than 1,500 miles. But when you plot these out on this ice ring, ice shore, whatever you want to call it, you're looking at anywhere from 20 to 30,000 miles trekking. We just know they didn't do it like that. It's just absolutely impossible. The math doesn't work out. Antarctica cannot be the ice ring.
Lawrence has shown this on several different occasions, both Amundsen and Scott's journeys, which are more contemporary than Captain Cook or any of those guys. And it makes you wonder why everybody keeps reflecting back on Captain Cook's journeys. Oh, he went 65,000 miles before, and he couldn't get around the ice ring and he never found an entrance into Antarctica. And then when you show them, well, let's just go look at maps of Captain Cook's journeys. He took 3 journeys, and that were, you know, recorded in diaries and put out later with maps showing where he went. And I'm sure that the diaries weren't, you know, redacted and kept secret from the world, even though they were given over to the Queen and her court, and they, you know, decided where everything went and what happened. So you look at those those expeditions, and, you know, he's all up in Arctic and back down the other side, and, you know, he's back over to Spain, and he's down in the Tahiti and all over the place. Well, of course he traveled a lot of miles. Was all of that spent, you know, trying to find an entrance into Antarctica? I don't think so. But since then, we have more contemporary information that should be, you know, as undisputed as Captain Cook, and that's what you were just talking about. So,
I'm not even convinced. What kind of proof do we actually have that Captain Cook even took these journeys past the poles that he's claiming? Outside of his claim that, well, I sailed to the North Pole and passed and I found the land of giants. I mean, is there any evidence to even support that he even took these journeys? I have more faith in these expeditions that were monitored by the world, like, you know, to the South Pole.
Yeah.
You know, that's in the 1900s. I have way more faith in that than some story that you're going to give me. Well, there was a sea captain back in the 1700s, you see, and he sailed to the land of giants. Already you're sounding real unscientific there. I'm not saying giants don't exist or anything like that. We're not here to argue that point. I'm just saying the claims were kind of outrageous that are associated with this. All these claims.
Thomas, can I just wrap up this Gleason map?
Sure. Yeah.
Yep, go ahead.
Okay, we've got this section here, and it says perpendicular barrier of ice. Yeah.
Yeah.
You can see that?
Mm-hmm.
Yep.
Okay. All right. Well, all right. Well, there's something else I've noticed about this map, and I won't see Laurie as an artist. She might be able to point this out. So I'm just going to zoom out a little bit and see if she can actually observe what I saw when you actually zoom into these quite closely. So let's just have a look. We did observe this when we were debunking. Do you remember that Buffalo Street map atlas that was doctored to make it look like the Litho company had actually done it? You remember that, Laurie?
Yes, the
let's just
Rand McNally map company. Mm-hmm.
So when you zoom into this map, on this high definition map, what do you actually see along these borders? What does that look like to you?
What do you mean, the pink lines drawn around?
What does it look like? What does it look like it's been drawn with?
It looks like it's drawn with a magic marker.
Felt tip pen, which wasn't invented.
Well, either that or Photoshop, which certainly wasn't invented then.
All this has been. These lines, look at these lines. They've all been sort of crudely drawn in.
Are those original, Lawrence?
Well, this is the official Gleason map, as it is, the world as it is.
Yeah, you're right.
I always use this one because it has the time keeping hands still left on it versus the one where they've been removed.
Yeah.
So this is the official one with the time keeping hands still on it.
Yeah. Lawrence, that's a real good. That's a real good photo there.
Done. When you zoom in, it's very crude, and it just looks like a felt tip pen.
It really does, or a magic marker. Yeah.
Anyway, let's just go back and look at the Captain Cook thing, because I've got that on my screen.
Okay.
Somewhere. Hang on, let me just take that down. Antarctic routes. Here we go.
Did you freeze up?
He froze up. That's a really nice screensaver there, or a desktop.
I'll try and make it a bit bigger.
I was just looking at that today.
I know. I'll zoom out. So this is obviously the green one here. This is where Scott started, and this is where Amundsen started.
Can you make that larger on the screen, Lawrence? Can you
Well, they won't be able to read the writing if we do.
That's where the Ross ice wall is.
Page.
All right. Okay.
But you might be able to make it. No. All right. Yeah, that's made it a bit bigger, hasn't it? Yeah. Okay. That's made it bigger. There we go. Full screen. So the point is, anyway, I mean, because when I put this together, over a year ago, you had to. I mean, the problem with these circular maps where they haven't got a south pole, because in reality, the longitude lines converge; they don't diverge out to an outer ring. So on the globe and on the diamond map, the 90-degree south is a single point. So everywhere on this line here could technically be the South Pole. I could only determine where the South Pole is by looking where these longitude lines converged on an actual map where they do converge, which is the diamond map, which is the most accurate one I've seen. So that is where it would be. But technically, if I took all this information off and I said to a Gleason mapper, please tell me where on your map the geographical South Pole is, they won't be able to tell me because it's not.
Well, they're going to tell you that there is no South Pole. That's going to be their answer. And if you remember correctly, I showed this exact meme, artwork, chart, diagram to Jaron and David Weiss when I was debating with them, and because you shared it with me and I shared it with everyone else. And of course, they said that's ridiculous that the South Pole's not on the other side. And I kept trying to drive home. Please look at the longitude lines. I mean, we actually do travel using longitude and latitude. So they're real, they're not like, there's no lines in the ocean, okay, and there's no physical lines drawn on the continents, but as far as mapping is concerned, they're used to find out where you are and where you're going. And so longitude 0 is opposite of longitude 180, right?
Yeah. So with a circular map, you have a big problem because on circular maps, there is one location that you cannot pinpoint because there's no South Pole. So they cannot say where the South Pole is.
So how do the stars? How do the stars orbit it then? You know,
unless Scott and Amundsen's expeditions were all faked back in over 100 years ago, then they've got a big problem, haven't they? Because the South Pole does exist. They did travel there, and there's a research station there now. But they couldn't have travelled on this map because they would have had to go actually, about 35,000 miles. And their entire journey was over ice. So they would have to go, Scott would go around that way. And Amundsen would go back around that way. And when Jerem was saying, well, how would they know when they got there, which way, how would they go back? Well, obviously they followed their tracks back because that's where all the food depots were. And Scott went that way, according to this. Amundsen went there, and Scott knew when he got there because, first of all, he found Amundsen's, their camp, but they used the sextant to determine what latitude there are. So it's the sun angle on the sky on a given day, which will tell you what latitude you're at, and that's what sailors do. So they know the latitude that they're at sea by taking sun readings at noon, and they'll have a chart to refer to find out what latitude they would be at a given time in the year, at a given time of the day. So they knew the South Pole because the sun angle would be, the maximum sun angle at the South Pole is 23.4 anyway. So it will be somewhere, not far off that. But they would have a chart, on every different day, the maximum sun angle would be X or Y. So they knew exactly where they were in terms of latitude. But on this map, it is clearly an impossibility, to walk on foot over ice, and Amundsen would have to have been walking, 632 miles a day. Well, a marathon's 26 miles. He'd have to be traveling like 25 marathon runs a day. Well, I did a marathon once and it took me 4 hours. So, you couldn't do 25 marathons a day pulling heavy sledges across ice in treacherous conditions. It's just totally impossible.
Well, Lawrence, there's also another serious issue here that people ignore or poo-poo or decide they're just it's wrong and they don't believe you. And that is, there are real people living in real places like Cape Town and in New Zealand and in Chile that are taking contemporary star trail videos, not even just time-lapse photography. I'm talking about videos where they're actually filming the video, filming the stars, so that no one will argue that you didn't do that, you did that in Photoshop. Well, obviously, the use of Photoshop is included because you put the film in there and you speed it up, or you put the individual photos that are taken over, every 10 minutes or whatever in time lapse, and you just meld them all together into a composite. But they all have a circular star trail at those three opposite. I mean, what longitude 180 on this Gleason map is somewhere close to, or 165 to New Zealand. And longitude, what is that? 30 is 15 is near Cape Town. And what it's covered up, but the south tip of South America. And there are different constellations in the southern hemi than there are in the northern hemi. And so the star trails are not the same in the north as they are in the south. That's a given. And they are circling. People are making, real-time videos. And so how do you have three different, that's just three different points of latitude. What if somebody wanted to take one off of a, stationary ship? It'd be pretty hard to do, to keep the camera still enough to take, time-lapse photography. But the point is, they're all showing circular star trails. Now, is there a pole at the end of every one of these longitude lines?
There would have to be. That's the only way you can explain it, because just like the Big Dipper orbits in a tight circle around Polaris, assuming Sigma Octantis was the South Pole star, the Southern Cross does the exact same thing in a tight circle. So where is this tight circle taking place at the south? Is it taking place below Australia? Is it taking place below Africa? Or is it taking place below South America? Where is our small circle?
Here's what happens next. Then you start hearing these ad hoc reverse engineered theories and speculations of, well, we all have our own personal dome, and we all have our own view from wherever we are of our own star trails and our own, sun and moon circling over, going over. And then there's, well, it's the way that refracts off the dome. Okay. Now you're adding a fictitious dome to a fictitious ice wall. And I'm not saying there isn't a firmament, but we don't know that the firmament is shaped like a terrarium dome or snow globe. So, you're just adding on more and more mythology and urban legend and flat earth dogma on top of each other to explain away the problems. And I have to keep reminding everyone, isn't that exactly what they did when they invented the globe? They've had years and centuries to ad hoc theories on top of gravity and spin and axis angle and vortexing and all the other things that they've added on to explain the anomalies that observers on the ground can see clearly with their own eyes. And and so are we doing the same thing inside the flat Earth that they did to us with the globe theories?
Absolutely.
So if you find yourself coming up with excuses for why you don't accept this information, then you have to stop and ask yourself, have I been cult washed? Have I been brainwashed into, just like Thomas started out at the beginning of this hour by saying, you know, I saw some amazing stuff and it really captured my creativity and my, you know, my inventiveness and my imagination. And then when I actually started checking into the information, you know, you hear the game show noise, wah, 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 wah,
Yep,
because now it's not holding water.
Yeah, and you think Scott and Amundsen, you know, if they were going to the South Pole and this map was actually real, they would have travelled down to Cape Town, got a boat from there to the ice wall there and travelled inwards to the 90 degrees. But they got it 180 degrees wrong. They were on the wrong side. I guess they had to be pretty stupid to do that, eh?
And you know, another thing.
Well, okay, now then there's going to be another theorist who's going to come up with, well, you know, they actually say that's just sort of the, you know, official South Pole marker, and that's not exactly where the South Pole is because it moves around because of magnetic declination and
yeah, but you know what?
more
that's not going to work. That's not going to work because the simple fact is he started out like say Amundsen. He started out at 168 degrees west and traveled to 0. Where is your 168 degrees of a circle?
Mm-hmm.
That's 25,000 miles. Where's your South Pole at this? Where's your tight-knit group of stars? All this stuff is, you just wiping out so much.
Yeah. Laurie, I sent you, I think on Facebook and asked you to start playing. You don't play it right now, but if you can load it up, because I just wanted to segue into this because I think there was some untruths told in that debate that you did. But you've seen this, but Thomas hasn't. Well, he might not. He might have done if he's seen the page. But this is testing powers of observations. This is from Google Earth. And the line going horizontally is along the equator, and the line going up is going straight north. And the line that joins them is just the line that I've used to join them up. So, Thomas, can you tell me how many curved lines you see there?
Curved lines, I would say just one.
Red lines.
Yeah, I'd say just one.
Just one, okay. So let's just come out of that one.
I see 2. The bottom one has a slight curve.
All right, well, it's actually
very slight.
Dead straight along the equator. Let's move, these lines are locked together now. So all I've done is twist the globe around. Now do you see the line that you thought was curved, Thomas? Can you see
what yeah, now it's straight.
Same line. So it just depends where you look at it on the globe. The angle that it's viewed from, that circular line now straight, isn't it?
Right. Now the other one's slightly bent.
And then we'll twist it round again onto this one. And tell me what you see now. How many curved lines do you see now?
2.
Yeah. So, you know, depending on where you look at it, a straight line can become a curved. You can have one curved line or 2 curved lines, and the ones that curve can actually change. So I want to segue from this, Laurie, to that. I'm going to stop sharing now. If you can play that hangout link from Jeranism Raw and play it from 212.
Okay,
play it for about 5 minutes.
Could you please tell me where you shared it with me, because I can't find it.
On your Facebook, on our message on Facebook.
Okay, there's about 10.
It's the most recent one that's menu.
The one that says chart plotting and navigation.
No,
Captain
on Facebook.
Lori, somebody. Okay, in our inbox, yes.
The most recent one in your inbox, yeah.
Okay. Flat Earth, no, that's the coin. Can you send it to me again, please, Lawrence? I can't find it. There's like plotting courses. There's 20 years of GPS. I just shared that with you today, Thomas. You were shocked that we've only had GPS being used on airplanes since 1994.
Yeah, matter of fact, I wrote that down in my notes here, and that's an interesting point. I like that while you guys are looking at that, let me talk about this point for a minute. For our listeners, GPS is not as old as you think it is. It actually was introduced on February 16th, 1994 is when the FAA put it in the airports for pilots' use. Now, today, when a pilot goes somewhere, let's say he's traveling all the way across the Atlantic Ocean, he'll set in a coordinate and his GPS will pretty much guide him. But before 1994, they didn't have that kind of system. The pilot actually had to be there, and they had to have radars, they had to have maps. And here's the thing, pilots have never used a Gleason map. Oh, is it coming through now?
Sorry, I had just found it, but go ahead.
Okay.
I'm almost ready.
My point is these pilots were not using, all you got to do is go down to your local airport and ask any pilot. Pilots have never used the Gleason map as a navigational map, ever. And so the thing is people keep saying, okay, well, if the AE is wrong, and I'll accept that it is, well, what map are you going to show me? They're all wrong. And I keep trying to tell everybody, no, they're not all wrong, because pilots have been flying almost every inch of our Earth on a daily basis. Thousands of pilots are in the sky every single day. They're not getting lost. And they were not getting lost before this GPS system in 1994. In the 1980s, you weren't seeing commercial planes just getting lost every single day. So obviously, somebody has a map. The map is well known. The map that we're presenting, your continents do not circle a central North Pole. The continents lay out like you see on a UTM map. I like to use the diamond myself, but we'll go into that later. But yeah, okay, that's pretty much all I really wanted to say about that.
All right, so can you see the video on my shared screen?
Yeah.
Okay. So let me make it full screen. Okay, and playing.
2 minutes 12, Laurie.
Oh, I thought you shared it with me where you wanted it to start.
No, it needs to start 2 minutes 12 and then play it for about 4 minutes.
2 minutes 12.
Sorry, 2 hours 12 minutes.
Oh, 2 hours 12 minutes.
Yeah.
That's a big difference.
Okay, start it there if you want.
Okay,
okay.
Here we go.
Have you got the
Kind of
sound?
muted. There we go.
The equinox is looking 90 degrees, but 90 degrees east of the equator. They're not.
You turn it up.
And that everybody thinks they look east on the equinox is because everybody's looking at the equator. That's why, and because the sun is above the equator. If you look here, no matter where you're at, 90 degrees east is to the equator. See, 90 degrees is here. So everybody's looking at the equator when the sun rises, and they think that that's east. But I mean, there's so much wrong with the globe. It's ridiculous. I mean, if you took somebody like here where I live, and you said, okay, we're going to go east. So this is right here, 80 degrees east, okay? So if we went 80 degrees, now if I drew a line, I'll save that. So if I draw a line here and you go back at it, shouldn't it be the opposite? You know, let's make it easier. Let's actually do 90. So let's say we go here, 90 degrees. Okay, so then we're going to go 270 coming back. So 90 is right there. Okay, so then somebody who's at this point should be, if we go 270 back the other way, so I'm going to go right from that starting point, 270 should be here, right? No, 270 is here. So there is, and this is what's called a heading, is if you really started to go this direction and you wanted to keep that heading, your compass constantly changes because you're actually moving off the North Pole. You keep, every step you take, you would adjust to your right, a little bit, a little niche, a little knock to your right, because that's what the compass does. It's always finding north. So this is your heading. You're heading this way west. You're heading this way east. So it's confusing because when you think of what we're on a flat land, if you're looking east and the sun is rising in the east, setting in your west on the equinox, it is doing a circle above you, but in your dome, you would see it rise perfectly east and set perfectly west. Well, everybody would, right? On the equinox.
Laurie, just stop it there.
What I'm trying to show you.
So what did Jaron just say? He said, in your dome.
Yes, he
so
did.
This is a new
that to be not taking it out of context, he had already explained that each of us have a personal dome that we inhabit or observe things from wherever we are on Earth. And
I actually have a theory that can go along with that idea a little bit. We'll explain that later on. But
all right, well, carry on playing it, Laurie, because there's some other crucial points.
It's the same
there.
on the globe. Because usually when I explain this on a flat Earth, people think I'm crazy, and I'm trying to show you first, this is the way it works on the globe. So it's not, I'm not making a crazy stretch here. What I'm saying is what happens on the globe is equal to what happens on the flat Earth. That
Stop it.
It's crazy. I mean, if you take any spot and go.
What did he just say?
Whatever happens on the globe happens on the flat Earth.
But what did Jaron repeatedly say throughout that hangout? He said you can't use globe Earth data.
Yeah.
Yeah, he sure did. He contradicted himself. Right
unless it suits his illustration, then you can use it.
Correct.
Anyway, carry on a bit further because I've got this
90 degrees east. You're not going to go east. Like people think if you were at this latitude.
No, I agree. Don't struggle with that because I agree. Lawrence and I did a whole hangout on that,
weird,
following a line around straight west or straight east, and you always cross the equator.
Correct. And if you do a rum line, right? Did you guys look into rum lines, which is the
we did. Yeah, we did all that. And so, Google Earth is useless as far as trying to draw an actual compass direction, following a compass.
Because if you got down, even though this is 90 degrees east this way, and it's going towards the equator right here, and then you did 90 degrees west, 270 west from here, you would think, because somebody would say, well, that's impossible because they're both opposite each other. Well, they are. If you go here and then go 270 west, 270. Well, if you got down to the personal size, like right here, if you got down here, these are right across from each other. You would turn around.
Okay, but the point is that most people think that east and west from their location would follow, like, say, a latitude line.
Correct. Yeah, but here, I mean, look, if this person looks this way and says, my sun is rising at 90 degrees east and setting at 270 west. Well, if you really pull back and look at what those lines are doing, they're not a straight line. We just don't realize that from our perspective.
Okay. Laurie, you there?
Yes.
Okay, now I'm going to share. I've actually captured the approximation of that curve that Jaron's done, and I'm going to show you what he's actually done to make you think that that's a curve. So I'll take the screen share again and bring up Google Earth. I've got it. Okay.
Mm-hmm.
Have I got this? So that's what Jaron was showing you, saying that was a curve, yeah?
Mm-hmm.
Okay. But when you bring this down, yeah, what does that curve become?
Straight line.
Yeah. That's what he was doing to trick you into thinking, and the viewers into thinking that was a curve. Obviously, when you move it up, it looks curved, but when you bring it down, it straightens up because it's a straight line. So
so the globe cannot. He's had it backwards. The flat Earth does not mimic the globe. The globe is trying to mimic the flat Earth. The Earth is flat.
Yeah.
straight lines can be drawn on the flat Earth, correct?
Yeah.
Okay, so if we were drawing these rhumb lines on a Mercator or a diamond or whatever, using lines, points at degrees, west, east, north, south, they would be straight lines. The only reason why they curve is because they're being shown on a sphere, which is what great circle routes are.
Yeah, I mean, any line that you draw on the globe, any line between 2 points will be part of some kind of great circle route. Every last one of them is.
Except straight lines
going
going up and down longitude lines, right? And the equator.
Yeah, but you could draw 2 lines anywhere that look curved and you could straighten them up because they're all, it doesn't matter which way you go. There's a great circle route every which way. If you do a full 360, it'll be a great circle.
Okay, so let's just keep this on here. And Thomas, can you want to jump back in with what you think Jaron was trying to say? Because, you know, I obviously want to be as fair as possible. And we're having some feedback from someplace.
Well, honestly, I didn't really have much to say on that.
You said something about the dome, the personal dome.
Oh, yeah, I had a theory of, now I don't know if we should go into that just yet because that also goes into the whole Enochian gate system, or as we like to call it,
we're not there yet. We'll save that. Okay. Right. So the point is, and we said this a long time ago, that the Earth is flat, and the travel routes that are the lines of latitude and longitude on the UTM are square, correct?
Absolutely. And we know for a fact that the military goes out, they actually send these surveyors out, and they literally survey every foot of these. These are the most detailed maps in the world. The United States military maps, these are the most accurate maps in the world. They don't put out fake ring maps or anything like that. They put out what they use. They put out what works. They use a square grid system called the UTM grid, and it works flawlessly. These soldiers go to areas where they've never been to before, and they use this square grid system, a perfectly square grid system, and they can navigate anywhere on the Earth they want to go, and they don't get lost.
Okay,
if the map's wrong, how are they not getting lost?
Okay, so people get all balled up about the, you know, the diamond or the square or, you know, the different shape flat maps other than the circle. And what they are getting upset about is, in my opinion, is that they're seeing a beginning and an end. They're seeing a left and a right. They're seeing a boundary by the paper. And so when you consider that it's the layout of the land that we all are most used to looking at, okay? And we do have plenty of high Earth or high altitude planes. I'm not even going to say low Earth orbit because I don't even use that language anymore. But high altitude planes, Google Maps and the Hubble plane that's flying around and other planes that can take aerial photographs of the Earth, they have it plotted out pretty darn correct. So if you take continent sizes and continent layouts and put them on any piece of paper and act like there's, even if you just wrote it on a big white board with no boundaries on the sides, top or bottom, just the land and the waters, that doesn't seem to bother people nearly as bad as when they see a square, a diamond, a square turned on its end diamond, an elongated diamond, a sinusoidal map, because then they get all upset because they hear Pac-Man, or they hear Enoch Gates, or they hear 4D, or any of these other terms that, for lack of any language that we have to describe these effects we're talking about, we're just sort of having to make them up as we go along. Now, obviously, no one believes Pac-Man. You don't, waka across the earth, come over on the other side.
No, that's not what's happening. That's definitely not what's happening.
It is nothing more than a euphemism, a saying, a use of a word to describe a concept. And so anyway, my point is, put all the land masses down there on a flat piece of paper with no edges or boundaries or lines on it, and try to imagine that as the flat earth. And when people start talking about infinite plane and stuff like that, the word infinite means you cannot identify an end. If you just kept going west for the rest of your life, okay? If Thomas got on a plane or in a ship and just kept going west, and he never turned around and went back the other way, okay? He would keep going until he came back to where he started.
Yeah.
And then he would keep going again. Now, that is one of the reasons why they've been able to fool us into believing that it's a ball. Because there is a place where you come back to, no matter whether you go polar circumnavigation or whether you go, around the middle at the equator, or whether you go across Greenland and down around, Australia and back up the other side. A ball is a ball. You will always come back. There's an equator line, imaginary equator line everywhere on the globe, right? You just set it at a different angle.
Right.
Okay. And so by definition, they have taken these agreed upon lines, longitude and latitude, for the purpose of international agreement. That's all.
Yeah.
They're not really there.
Right.
Just like the edges aren't really
not
there.
But the sun actually travels certain, the
circuitous routes. Exactly.
Right.
Now, how are we able to fool people into believing that the sun goes off one side and comes back the other? That's why circle maps were such an easy sell, because it didn't take a lot of imagination to be able to understand that it's just going in a circle. I mean, I heard David Weiss on a UK radio show a couple days ago explaining the flat earth to these two guys who were being really big buttheads, I have to say. I mean, I wouldn't want to have a conversation with these two guys for my life, because they talked over him. They didn't give him a chance to finish a sentence or anything. But when given the opportunity, he said, we live on a big circle that's surrounded by ice, and the sun goes around in a circle in the center, and the sun literally, I'm pretty sure, I'm close to paraphrasing, but I'm close to quoting, okay? He said, the sun goes around and melted the ice and made this big pond in the middle that we call the earth. And it's surrounded by ice. So
that's insanity.
So that's how people are explaining the flat earth to newcomers. This guy had every rebuttal ready possible to say why this and how come that and and of course he didn't give David a chance to answer. But once you hear that, what else you got? The melted the ice in the pond, and I can't sit still and not say to people who are who are globe earth skeptics, that's as far as they've come. They are not flat earthers. They are doing some research. They are following along with what's going on in the flat earth community, and they hear stuff like that, and that's the reason why they listen to our podcasts, because we explain, sorry that you had to hear that, because we don't believe that, and not everybody that calls themselves a flat earther believes that.
Yeah. Laurie, can I segue into something else to correct another mistake, because we've done with that one? But before I do, I want to ask you and Thomas, give me your estimation of the distance from the top of North America, not these little islands above it, to the tip of South America. How far would you say it is?
I haven't.
Okay, and ask the question again. I was clicking around and I wasn't paying attention. I'm sorry, Laurie.
How far would you say it is, Laurie, from the mainland? Forget these islands at the top. From the top of North America to the tip of South America, how far would you say it is approximately?
I'm Horseshack. I got it. I know this one.
I'm going to guess about, that looks about 1,600 miles, I would say, at least 16 to 1,800.
No, the top of North America to
all the
tip
way to
of
the
South
tip of South America. It's about 10,200 miles, Lawrence.
Okay.
10,600 miles, something like that.
How far would you say?
From how far? What was the 2 points?
Okay, the land at the top of Canada, so to speak, the top of North America.
Right.
To the tip of
all the way down through North America, Central America, and South America to the tip of South America.
Okay. Well, I can't give you an exact number. However, if we go with ball measurements, we know that the prime meridian is exactly half of the equator. We know the equator is 24,901 miles. Therefore, we know the prime meridian is 12,450. Right. So this means a little less than that. You're looking at about 10,500 to 11,000 max, but I wouldn't say, no, 11,000 is too much. I'd say 10.
All right, let's measure it. Let's measure it. Obviously, I can't draw directly through South America, but we can go down to the point where it ends.
Right. Yeah, right. We get the idea, yeah. Well, actually, it almost comes together there. Yeah, look at that.
So it's about 8,500 miles. Now, Laurie, what did Jaron say the total distance from pole to pole was?
About 8,000 miles.
So the Americas alone are 8,500. Now, how far is it from the tip of, the top of North America to the pole? It's probably another 2,000 miles, isn't it? What's that?
Well, yeah, that's why I was going from, like Alaska, the tip of Alaska. You went below that. I was going from the tip of Alaska all the way down, and that's where I got 10,200 miles.
Top bit's another 1,500 miles,
and
then if you go from the tip of South America to the center of the South Pole, it's another 2,300. So you've got another 4,000 miles on top, which gives you your 12,500 miles. So let me come out of that and show you something else. Let's go to this screen. Here we go. So here we go. This is from Wiki. And now it states here on the Wiki, the azimuthal equidistant projection. This is all standard stuff that any cartographer will tell you. The azimuthal equidistant projection is an azimuthal map projection. It has the useful properties that all points on the map are at proportionally correct distances from the center point. So everything from the center point outwards is correct. So from the center to the edge, it's 12,450 miles. And some basic trigonometry, using that to work out the surface area of this circular map, comes to 487,000 million square miles, which is 2.5 times that of the globe. Now, what Jaron did, he reduced this distance to 8,000 and multiplied it out and got virtually the same as the globe. Well, obviously, you're going to do that. You just adjust the numbers so it fits the one you want it to come to. So there's some more deception for you. These are you know, all cartographers will tell you. Now let's look at latitude. Okay.
Just in case, Lawrence, hold on. Just in case there are those out there, the deniers who say, "Oh, you've got to be kidding me! You're using Wiki." Okay, you're using Wiki information. The reality is, Thomas said it at the very when he was guessing, or he was coming up with his answer. The distance from the pole, from the North Pole to the South Pole, at the prime meridian, or at the, what's the other one? International date line on the opposite side, is 12,000, half the width of the equator. So we all agree, everybody's always half the distance of the equator, correct?
Now look at that Gleason map. If you look on the side of that Gleason map up there, it'll say longitude and time calculator. Notice the word latitude is nowhere there, because latitudes are not correct. That's why it's not there. That's why it's telling you longitude and time calculator. This is a clock to tell you where the sun is when you're at sea. This is
it's also a timekeeping device that is to be used by people who want to see what time it is in another time zone someplace else on Earth. So if you're in the UK and you want to see what time it is in Zimbabwe, then you take that little arm and you swing it around. And
they conveniently tore off.
Yeah. So that's the whole idea. It originally was created for, as far as I have heard, and I did research that too, it was created for a teaching tool, mostly for the schools, and that was the first place that they were using it, was in the schools. But the actual Gleason map that you see is not the one that Gleason created. That one was never printed. The one that he got a patent for, or patent as Lawrence calls them, was a black and white drawing with the idea of it. Yes, not the printed version that everybody's using.
Yeah. Okay. Now can I segue into the next part of this presentation? Okay. So, Laurie, Thomas, do you know the distance between 1 degree of latitude? How far it is in miles?
1 degree of latitude.
UTM is going to be one thing, but it's going to fluctuate on this Gleason.
No, it's an exact
on the Gleason or on an AE?
No, on the Earth. What we use for navigation. Everybody, a sailor will measure 1 degree of latitude as a given number of miles.
Okay.
As will some.
I don't know that in my head, but I did know. I've found it before.
It's 69 miles.
That's right.
However,
I was going to say 65, but it's
69.4.
Yeah, correct. And this distance from pole to pole is actually 8,000 miles. Well, first of all, we would have guessed it. We would have spotted that they were lying to us big time. You know, when they converted the globe, the flat Earth map to the globe, they had to keep everything else as near as accurate as possible. Otherwise, it would have given the game away. So, albeit it's shown on a globe, the distances are correct because they're used by navigation. They're used by sailors. They make calculations. They need to know how far it is and how long it's going to take to get there. And as you so eloquently said, Laurie, on the show, the airline pilots need to know how much gas to put in the plane to make sure they get there. So,
Lawrence, I'm sorry, go ahead. Sorry.
In Gerard's world, the 69 miles of 1 degree of latitude is now reduced to 44 miles. But you can go and check for yourself to see whether this 69 miles is correct. So let me move on to the next bit.
And I just Googled it, and you are correct. I Googled it while you was talking. 69.407.
What we're going to look at here is a flight from Bristol to Edinburgh. Okay. Well, first of all, we're going to look at what it is by road. Now, obviously, when you travel by road, you're going all over the place. It's not a straight line. And it's 405 miles from Edinburgh Airport to Bristol Airport. Okay, but when you fly there, okay, this is almost due south. Okay, and I've put the latitude and longitude of all these, and the difference in latitude is 4 degrees 34 minutes. 1 degree of latitude is 69 minutes. 1 minute is a 60th of 1 degree of latitude. It's 1.15 miles. Anyway, when you multiply it out, 4 degrees 34 minutes equates to 315 miles. Now, I've drove up to Edinburgh. I know how far it is. Those figures are accurate. Yeah. If it was only, 64% of that, then it would be about 200 miles. And I know for sure it ain't 200 miles because it's 200 miles to Edinburgh from where I live, which is like from about there. So let's just now take a look at something else. Here's the flight distances, which I've got independently. That comes to 312 miles. And I computed it myself using the 69 miles to 300, and I was about 3 miles out. So near as damn it, the latitude figures are correct. Now, you could do this yourself. All you need to do is go over a map of America and find a road that's going north-south, one that's going 69 miles, and see how much latitude it is. And you'll find that 69 miles on a north-south road is 1 degree of latitude. So that disproves Geron's assertion that it's 8,000 miles from pole to pole. It's 12,500 miles. And if you can prove it on 1 degree of latitude, then obviously all the degrees of latitude are the same. Add them all up, and you've got 12,500 miles and a surface area of 487 million square miles, which is 2.5 times too big. Now, if it's 2.5 times too big, particularly on the outer edges of it, then the distances between places are going to be stretched out, and that's why the Sydney to Santiago route just doesn't fit. Now, what Geron did there, he pinched a bit here, he pinched a bit there, pinched a bit there, he increased the speed of the planes, then he looked at flight speed.
And the altitude.
Yeah, and then he looked at wind speeds, and he was quoting them in kilometres, and then he used the kilometres numbers and converted them to miles without telling you. Anyway, if you pinch a bit here and pinch a bit there and add all these miles on, you can make it almost fit, but which is ridiculous because he's having to skew all the figures to fit something that's, far too big.
Well, and of course, he's going to add in more things like, these, unbelievable jet streams and these unbelievable currents and so on and so forth. Well, anybody who has done any research into those who have made boat sailing trips around down Antarctica, of course, they're going to tell you all about these horrific I just lost the word. Not the jet stream, the other one, currents. And yeah, but does that make up for all that extra area? It doesn't. That's the point. We're losing. You're breaking up there, Lauren. Okay, you're back. Okay, so there's a big difference between calling someone a fabricator, calling someone a liar, and calling someone that's uneducated and doesn't know. Now, I'm using those words because they've been used on me, okay? Not particularly by Geron or anyone else. I'm not calling out names. But when you keep adding up false information to fudge your theory, are you doing science? I mean, I showed you, Lawrence, that he did post right after the debate that we did. This old video of, what was his name? Dewey Graham, talking about the difference between inductive and inventive reasoning or science or logic. And whether you, if you find problems with your hypothesis, do you just throw the whole thing out and start all over and reinvent? Or do you adjust the hypothesis to work with the new information, the new observations that you have. So I don't know what that was for, and I did feel that it was directed at us for the sole purpose of, you guys are inventing Pac-Man and diamond maps and the fourth dimension and whatever else, and we're not inventing anything. What we're doing.
Here's the thing. I don't have to provide any kind of replacement to prove that this Gleason is wrong. The Pac-Man just happens to be my personal map. Yeah.
Well, and that is where we are. We're being boxed in that, oh, well, you have this stupid map, 4D, you have all this Pac-Man and inventive stuff you can't prove.
But no
one's asking anyone to look at what we're working on or come on over to our side, or you have to believe in Pac-Man if you don't believe in the Gleason. There is no replacement, but there's no replacement for the globe. And until someone came along and said the replacement for the globe is the Gleason, and we're saying no, it's not. That's all we're saying.
Exactly.
And then from there, we're doing our own personal, private, and investigation and sharing it with other people.
Exactly.
We're not insisting that it's Pac-Man or it's the globe. We said that in jest to drive home a point, and basically, I defended that. It is Pac-Man or the globe. Pac-Man is an analogy for what must be happening for a flat map, a flat model to work with regards to travel, both on the land, terrestrial travel, and celestial travel. Celestial travel meaning the heavenly bodies are moving day after day, year after year, from east to west. And there it is again. The next day, there it is again on the flat map, and it's not going in a circle. So what is your inductive reasoning to that, and what is your inventive reasoning to that? Do you understand what I'm saying? That's how we arrived at it. Now, if we find some reason why that absolutely doesn't work, well, then what do you think we're going to do?
Well, here's the thing, Lori.
We're going to throw it out, and we're going to, start in another direction. That's all we're doing. We're investigating.
Right.
But that has absolutely zero to do with the circle map and model not working. Zero. We don't have to there's no law that says if you throw out the flat earth map, you got to replace it with something else, partner. There's no law like that.
Right. It's a standard argument you hear all the time. Like, if you want to throw out one thing of science, you can't unless you have something else to replace it.
Right.
And here's the thing. And anyone can do this. Just get on Google, go to Google Images, and just type in world map. And that's it. Don't be any more specific than that. And I'm telling you now, when you go down there, you won't see that Gleason map for starters. Every single map projection there, whether it's a UTM, whether it's a Lambert, whether it's a ITOF, a sinusoidal, they're all Pac-Man. And the continents, there's only one possible continent layout. On the circular A Gleason map, you have a central North Pole, and the continents literally circle around that. And that's a northern view of a ball, but that's not how reality works. Again, we were just talking about that latitude. The latitude's constantly expanding the further south you get, and everything's getting more and more stretched out. It doesn't work like that.
Well, one thing, Lawrence, you went into, and I went into it in the debate about standard parallels. That's another issue with the circle map. Standard parallel means all lines of latitude are the same distance apart, correct?
Laurie, what it actually means is a standard parallel is a line of latitude that's true scale. Okay,
True
it's
scale.
accurate to true scale. Okay,
Okay.
and on the Gleason map and the AE map, the only standard parallel is a 45 north, and all lines of latitude within that are too
Inside that.
small,
Too small.
and all the ones beyond that are too big.
All right.
Which is why they have problems.
Now, the reason why I brought that up is I just noticed on the the AE map that you just had up on the screen a little while ago has what looks like the lines of latitude are the same distance apart. And then I've seen others where they get wider apart as they go out. Not just the lines of longitude spread out, but the lines of latitude spread out, correct?
Well, the distance between them stays the same, but they form bigger and bigger circles.
Yes, right.
The distance between them is the same.
The distance between them is the same on both models?
On the circular map, the distance between them is the same, yeah, but as you progress
longitude's fine,
toward the ice ring,
no, I'm not talking about longitude, Thomas. I'm talking about the lines of latitude that they get farther apart as they go out in
exactly on the Gleason, right.
In comparison to the distance between them from 45 up.
Let me bring it up.
It'd be like, look, a ball on a ball.
Let me make sure I'm making myself clear, because somebody's going to take this all and like make me look like an idiot. What I'm trying to make myself clear about is the lines of latitude. Are they equidistant inside 45 on a Gleason and outside on a Gleason, outside of 45, beyond 45?
They get progressively larger.
The distance between all the lines of latitude on the Gleason are, they're at the correct distance apart. They're equal distance apart, but they're the lines are all inaccurate apart from at 45. They're all either too big or too small.
Okay, the lines are too big. Distance around, or
let me bring it up.
See, that's what I'm trying to define here. Is
let me bring it up,
because it does relate to area.
It's the same thing when I was describing Capricorn and Cancer on the sun, where Capricorn and Cancer are both the same size, 18,340 miles. Mm-hmm. But yet Capricorn on the Gleason map is projected way too large because, again, that latitude line is getting progressively larger the further south you move.
And that I understand, and I agree with. The distance around the circumference of the circle is larger.
Right.
Okay.
Right.
What I'm asking about is on all these azimuthal maps. I've heard azimut. I've heard AE. Okay. On all these AE maps, and Lawrence just said that the distance between the lines of latitude is the same distance all the way out as it is from the standard parallel line.
Oh yeah, I see what you're
45
saying. Yeah,
in to the center. Okay, that's the point I was trying to make. Sorry it took me so long to make it.
Except for right there, right around there, looks like, what's that line? Yeah, it looks like all 1 inch is like it's 1 inch apiece.
Yeah, the ones going out, because you've got the thing in the middle. You see the little thing in the middle?
Yeah.
Yeah. You can see that these are equally spaced out. This bit's been broken off, but you can see 15, 30, 75, 60, 45, 30. They're equally spaced out. Okay. But obviously, once you get beyond, so you got the 45 there, that's to scale, but everything within this 45 is too small, and everything beyond the 45 is too big.
Right.
And which is why Greenland is so small in that map compared to, and why Australia is so big.
It's about 5,000 miles across when it's only about 2.
I heard it's the same width across as America by people from Australia, which is roughly 3,000 miles. And it's way bigger than across America, across Australia on those maps.
Well, yeah,
Way
it's
bigger.
wide. Australia is
Wider.
wider than America. Look at the width of that, and then look at the
Sure.
width of the United
That's what I'm
States.
saying.
It's further across Australia than it is across
If
the United States.
America is 3,000 miles across in real time, across the not the widest part, but the, you know, the coast to coast, typical across America.
That's much bigger.
Yeah, much. So,
Yeah.
that's a new one though, Lawrence, about the nice crisp coastline of Antarctica ice ring. It's almost razor sharp. It's so perfect.
Let me ask you
That's
though.
one I hadn't noticed on the Gleason, but you study that map more than I do, and notice all those little things.
So you've got the equator line here going round here.
Mm-hmm.
Now, this was another inaccuracy that came up in the debate, where both Jaron and David Weiss and Bob Nodell as well states this, that traveling from east to west is going round in a circle. I've done some research since, last couple of days, which proves quite conclusively that airline pilots are not automatically adjusting their navigation because east-west is going in a circle. I mean, prior to GPS, pilots would use the ground-based stations, the tracking stations, and they're flying they're flying on fixed bearings, and they'll go from one tracking station to the next. Let me just bring something else up, which is about run lines, which Jaron mentioned. You can see, read all this.
Pilots constantly turn, or do they constantly dip their nose down?
Let me read this out. The early navigators soon gave up great circle navigation, or Thordoromi in Francais, as a bad joke when they realized that when sailing along a great circle, the bearings change constantly, which would be the same if they were having to travel on a Gleason map. They would have to continually adjust their navigation to account for the fact that going east-west was in a circle, but run lines are fixed bearings.
You're saying, okay, so let's be clear. If they were flying the equator line, the line of latitude known as the equator, if they would, over a long haul, they would have to be adjusting to stick to that equator.
Yeah, as Darren said, the nose of the plane would be banking round all the time to complete a circle, but they don't do that. They obviously, on the great circle routes, which is not a fixed bearing, great circle routes are changing all the time, but that's done by GPS. Prior to GPS, very few flights use great circles. There's lots of information today. If you go to our Facebook page, I've put a whole ream of stuff about it. In fact, I actually gave you a link to a video, Laurie, if you can share that. It's the one where you said great find, and play that for us, and then people will be able to see for themselves that these are fixed bearings. Go back to the Facebook page.
You and I need to take little breaks on link sharing back and forth. Okay, well, is it on the group page? Is it on the group page?
No, it's on my message to you. If you go and find that, do you want me to find it and put it on the bottom?
Okay, here I got it. ATPL course general.
Yeah.
All right. Let me cue that up. Let me cue that up. It's Pro Pilot. And let me get my mic in here so I can screen share. Open the screen share. Where is it? There we are. Okay, this one, share. All right. Let me make that bigger. And here.
All meridians converge to a point at either pole. Depending on the proximity of a track to the pole and the relative angle, track direction can change quite rapidly. Sometimes it is useful for ease of navigation to follow a track that does not change direction. Constant changes in track nowadays do not pose a significant problem, as technical advances in navigation equipment can easily cope with constant track changes. A line that does have constant direction is called a rhumb line, and this line will cut each meridian at the same angle. A rhumb line therefore has the advantage of a constant track. From the diagram on the screen, we can see that a typical great circle track follows a different path over the Earth's surface to the rhumb line track, between the same departure and destination positions. The disadvantage of flying a rhumb line track is that it is not normally the shortest distance between 2 points. However, there are some special cases of rhumb lines that do create the shortest distance, in addition to being of constant direction. For example, the equator. The track along the equator is either west or east. It is a rhumb line as the track is constant, but it is also the shortest distance between 2 points, as it is a great circle. Another is a meridian. A meridian is both a semi-great circle and a rhumb line. The track along a meridian is either north or south. The equator and all meridians display qualities of both great circles and rhumb lines. They follow the shortest path along the Earth's surface, and they are also of constant direction. The rhumb line is always nearer to the equator than its corresponding great circle path. The shape of the rhumb line can be described as convex to the equator. Conversely, it can be described as concave to the nearer pole. In the picture on the screen, you can see that the rhumb line direction is constant between A and B, whereas the great circle track is increasing from approximately 060 degrees to around 100 degrees. The rhumb line track is approximately 070. In this next example, we can see the rhumb line track from Moscow to Vancouver. It can be seen that the path of the rhumb line almost follows a line of latitude, in a constant westerly direction. The great circle track, on the other hand, has a northerly track, a lot closer to the North Pole. The different paths that the rhumb line and great circle follow can be seen even more drastically when portrayed on particular maps, as can be seen on the screen. Comparison of the rhumb line and great circle tracks on a global scale are depicted on the screen. You can see that in the northern hemisphere, tracking easterly, that the great circle track starts at 030 degrees and finishes at 150 degrees. In other words, the great circle track is increasing. When flying in an easterly direction in the southern hemisphere, it can be seen that the great circle track is decreasing from 150 degrees to 030 degrees. When flying westerly, the opposite occurs. The great circle track is decreasing in the northern hemisphere and increasing in the southern hemisphere. An easy way to remember what happens to the great circle track in relation to the rhumb line track is the mnemonic DIID. The image shows 4 segments, the north and south hemispheres, and a westerly and easterly track. For example, in the northern hemisphere on a westerly track, the great circle path is D for decreasing. And in the southern hemisphere, in a westerly direction, the great circle track is I for increasing. This is a useful aid memoir and is used to solve many navigational questions. To summarize, we have seen that a great circle is a circle on the surface of the Earth whose center and radius are the same as that of the Earth. It also prescribes the shortest distance between 2 points. Vertices are the most northern and southern positions of a great circle track. Small circles are circles on the surface of the Earth that do not have the same center or radius as that of the Earth. A rhumb line is a line of constant direction. It is also important to recall the aid memoir, DIID, to solve some navigational problems.
Yeah, so the conclusion from that, Laurie, is that obviously sailors up until, you know, the advent of GPS would always use rhumb lines, which are constant bearing. They're not changing every 5 minutes because they're going in a circle. They're traveling in a straight line, you know, on a fixed bearing. And it's the same with pilots. You look at the ground-based systems. There's these transmitting towers that are all over America. And you can look at the maps and they're all straight lines between them. They are not making adjustments constantly to get from A to B. So what Jerry and David were telling was completely untrue.
Can I say something about something I find curious that, oops, I still have you on screen. Something that I find curious, and that is they showed, this is like trying to imagine, why is the rhumb line curved? Because they're showing a straight line on a globe. Yeah. So of course it looks curved. That's a fool your eye thing, okay? They can't show you a rhumb line on a flat map, on a UTM, for example, because then that would say, well, of course it's straight on a UTM because it's flat, right?
Yeah.
It's like, you see what they did there? So they double fool you to show you the Great Circle route on a sphere. And then they also show you the rhumb line on a sphere, and they both curve. So you're like going, why are they both curving if it's a straight line? And that's why.
But
on a flat surface, it would be straight.
Yeah. The reality is this, that Great Circle routes are the shortest route between two places on a globe. But if you use the same routes on a flat map, they're considerably longer. So let me just bring up Google Earth again and demonstrate for you.
Okay.
There we go. Share the screen, and we'll look at, let's have a look. Let's go to Seattle. Seattle Airport. Search. It'll come up in a minute. Hopefully. Here we go. Here's Seattle. And we're going to fly from Seattle to somewhere around about London. So there we go. So let's draw a line. In fact, I might actually have it on here somewhere. Let's have a look. JFK, temporary places, Anchorage into. There we are. Seattle to the UK. Let's put that line up and then zoom out. Okay, so on there we go. There's Seattle to the UK, and if I just twist it round, you can see that it would go that way. The rhumb line would be, you know, if this was a flat map, it would be, the rhumb line would literally follow the 50 degrees. You see the N50? Seattle's just below 50 and London's just above it. So the route would gradually get onto the 50-degree line and go up to 51 or wherever London is. That would be the rhumb line, if you can imagine that this was a flat map. And in reality, the rhumb lines are actually shorter than Great Circle routes. So when these, I actually believe they are flying some of these Great Circle routes, because I went on and looked at some videos of people who filmed their flight from Seattle to London. You couldn't see Greenland beneath them, but they'd got the on-screen viewer which showed them where they were, and it showed the Great Circle route passing through Greenland. So they're actually flying further than they need to, and they're wasting time and they're wasting jet fuel.
Well, that's why they're saying they're taking the jet stream, right?
I don't know about the jet stream, Laurie, but I mean, the crazy thing is they're doing that. If they are doing that, it's just to preserve the illusion that we live on a globe. But I looked at what was happening in the United States prior to GPS, and people were not using great circle routes. They were using run lines to go across the United States. And the same sailors have always used run lines. They've never used great circle routes because they wouldn't have time to sail the ship and put change the sails and do all the jobs that a sailor has to do. They would just be spending all their time adjusting their navigation. It would be nigh on impossible. The reality is you could not navigate on the globe. You get hopelessly lost. So that they use run lines.
Can you pull that globe down to see if how much that line straightens out, or if it does?
Yeah, it's a straight line on the globe. There you go. But when you put it back up to the normal globe, it looks like it's a big curve. So if you were going to use a run line, you just follow that line of latitude virtually all the way across, which is in reality is shorter than that. So if you plotted these routes on a flat map, the Great Circle route is obviously longer because it is.
Okay.
So
all right, let's. I think trying to play this back and forth game with going from flat maps to circle maps to globes, and comparing all of this is not only confusing, but I think it's treacherous, because you have, to use the data, distances and stuff like that. Like Jaron said, it's 8,000 miles from the North Pole to the South Pole, because there's a hump. And I didn't get the opportunity because we segued off into somewhere else. But I'm like, a hump on the globe, because it's not a hump on the flat Earth. So that's where things start to get a little switched up, I guess, is when you're cross-contaminating the data. You're using too many different versions of trying to explain something. So to me, showing something on the globe on Google Earth, we've been over this enough times. To me, it's dishonest, because the lines don't work, the lines curve, blah, blah. It's a globe, okay? And a flat surface, flat Earth wrapped on a globe, we already know that it can't be done. I mean, every map maker's tried to do it throughout history, is to try to put a flat map on a globe, and it's either doesn't fit because there's not enough, or it's too big and flops around over each other. Trying to put that AE map on a globe, we talked about that, Lawrence, about the pizza. If you took a ball of pizza dough and you rolled it out with a rolling pin to make the globe into what we call the pizza map, the area is going to get bigger, right? The overall area. So, okay, I want to segue back to you, Thomas, and I'm sure you have a couple of things that you'd like to jump in there. We're getting close to 3 hours, I think. 7, 8. No, it's not too bad. So
2 hours recording.
2 hours. Okay, that's nothing for us. So wow me with some of your brilliance.
All right, let's see what else we have here. I've got still on the idea of problems I found in the Gleason before moving on to alternative maps. One experiment people can do is Sydney, Australia. Get your circle map out, your circle AE map out, find Sydney, Australia, and you're going to measure 2 lines. One line is going to be from Sydney to Dallas, Texas. The other line is going to be from Sydney to Santiago, Chile. Now, go on your Google and pull up flight times you will find out that in order to fly from Sydney, Australia to Dallas, Texas, it takes 15 hours and 25 minutes. To travel from Sydney, Australia to Santiago, Chile, only takes 12 hours and 20 minutes. How does it take 3 hours longer to get to Dallas, Texas when Chile's farther away?
On that map.
Yeah, you can actually Google the airports. Just type in flight calculator and type in these two places. Type in Sydney, Australia to Dallas, Texas, and they're going to say it's 15 hours, 25 minutes. Then type in Sydney, Australia to Santiago, Chile. Only 12 hours and 20 minutes. 3 hours shorter, but yet it's way, way farther away.
Well, and you know that for several years now, the arguments have been, A, the Sydney to Santiago flight does not exist. You cannot fly it. They made that up.
Like the South Pole doesn't exist too.
They made that up. It doesn't exist. And then the second one is that the planes fly higher and go faster in the southern hemi than they do in the north. That's another argument. Legit as they can sound, they look you straight in the eye and say that well, the planes are flying faster down there. Well, I mean, anyone can look up Qantas and the airline.
That's exactly what I used. Yeah.
And any airline that flies in the back and forth in the southern hemi, and what type of planes they have, and they have them all listed, how fast they go, how much they weigh,
600 mile an hour.
And
600 mile an hour.
You can ask any pilot who flies that route, or the information is available. How high are they flying? What is their cruising altitude? Is the jet stream like 10 times, 5 times, 4 times faster in the southern hemi than they are in the northern hemi? I mean, anyone can look and see this information, but denial has been the name of the game for several years now. Once people hear this information from one of their, flat earth gurus, then it must be true because they said it. Absolutely. And don't bother to look it up, and don't bother under any circumstances to listen to any opposition research. Don't listen to any opposition. Don't listen to Vsauce or don't listen to Cool Hard Logic. It is against flat earth rules to listen to anybody in opposition to flat earth, because they make stuff up as to why the AE map doesn't work. And that's what they believe. And if you post a link from any of the opposition research websites, channels, YouTubes, why would you post that? Why would you drop that link? Jaron said that to Jake Gibson, flat earth asshole. Why would you drop a Cool Hard Logic link? Because he calls, flat earthers flat-tards. Well, we call globe earthers globe-tards. I don't, but people do all the time. That's okay though. That's okay. You can call each other all of the tard names you want, but if they can back up their data and their information with reality, okay, people actually do fly between Santiago and Sydney, and between Cape Town and Santiago. I mean, these flights are happening, okay? They're not all the time, and they kind of take some weird circuitous routes from time to time.
Well, you know what? Hold on. Now that you mentioned that, let's talk about that just for 1 second. I wanted to add in. I have a lot of people that like to tell me, well, how come I can't get a direct flight from, say, Africa to New Zealand, or from the United States to New Zealand, because New Zealand's like the furthest away. Well, here's the thing. How many people in the entire world are going to New Zealand on a daily basis? First of all, should every single airport in the entire United States have a direct flight to New Zealand?
Not only don't they, but it is not, if it's not profitable. I mean,
Exactly.
not even break even. They're not interested in break even. They're interested in profitable. Okay.
Exactly. So when you're trying to
So you
save
have to
hospital,
wait your turn to go there when they decide they're going to have enough bookings to create a flight.
exactly. And that's why when you're flying, okay, like say a common one they'll try is flying. You can't usually get a flight from the lower tip of South Africa to Australia. They usually stop up to India, and they say, well, how's come on this ball or on the UTM they fly north up to India, you know, before they come to Australia? Well, the simple fact is there's not enough people coming out of Africa that's trying to get to, you know, Australia and New Zealand. The common point, the common portal is India. Everyone in the world's basically flying to India, and then India's flying a regular route back and forth to New Zealand and Australia.
Right.
Because there's just not enough population.
It's like a hub. It's like if you live in the United States, if you live on the east side, east half of the United States, wherever you're going to go, you're pretty damn sure going to go through Atlanta. Okay.
Not much
Now
activity.
there's some other, you know, hubs that have been growing as time goes by, and it's the same thing out west. You're going to go to Houston, or you're going to go to Denver, and then you're going to get a connecting flight, unless you really want to pay some money. And so, but to say that these flights don't exist, and I know where that started. I mean, I'm pretty confident that the first time I ever heard it out of anybody's mouth was Mark Sargent saying that those flights don't exist.
I found it at least 10 different airports. I know they exist. I know they exist.
Okay. So the fact that they exist, and the fact that they're, you know, these times do not support these distances.
No, they don't.
Is
I've got more.
Oh, I'm sure you do. Go ahead, take it away. I have to take a break for a second, so you guys talk. I'm just gonna go off camera and mute.
Go ahead, Lawrence. What was you saying?
Thomas, you were just saying about why is it taking longer to get from Sydney to Dallas than it does from Sydney to Santiago? It's actually 1,500 miles further to Dallas than it is to Santiago.
Yeah, on the real map, yeah.
Yeah.
Okay, another thing. So we got outrageous distances that can't be explained on the Gleason, because the problem is, here's the thing people need to realize, is on a ball Earth, the northern hemisphere and the southern hemisphere both have equal area, because the equator goes down the center of the ball. So you have equal area on top, equal area on the bottom. Well, when you look at this smashed out pizza pan, you get the northern hemisphere is the right area, but once you get past the equator, it's supposed to shrink back into a ball, but it's not. You're just smashing it further out. The south hemisphere on the Gleason map actually has 5 times the area than the northern hemisphere does on the Gleason map. So yeah, it just like we was talking earlier, you know, when Capricorn and Cancer they're both the same length in reality, but yet on the Gleason map, the Cancer is almost twice as small as Capricorn is large. So again, we got that. Plus another thing we have to deal with is the Gleason map says that Cancer, the equator, and Capricorn all bend in the same direction. We know for a fact that the sun does travel Cancer, it does travel the equator, it does travel Capricorn. If you stand on the equator and look, you will notice that Capricorn bends up to the north, and Cancer bends up to the north, Capricorn bends down to the south. This tells you the sun is going to the north when, it's setting in the southwest in the summer, and in the winter it would be setting in the northwest, and in the winter it's setting in the southwest. My point is it's going in the complete wrong direction. If you look on your Gleason map, this is another one. Australia. I've watched these guys do this experiment. In Australia, in the wintertime, they're watching the sun come in at 90 degrees southeast and the sun set at 270 degrees southwest. That means the sun has to bend the opposite direction that they have Cancer and the equator bending. Even if I say, okay, you have a bending equator, I'll give you that, and I'll give you a bending Cancer. Well, the fact is Capricorn bends the exact opposite direction. That's why in the Australian sunrise comes in at 90 degrees southeast and sets at 270 degrees southwest. Because it gives that arc that goes in the exact opposite direction of what it's supposed to. And that's caused because they just decided to pretend there's no South Pole and pretend that all those stars there don't exist, pretend the southern lights extend 65,000 miles around an ice ring. So we also have the problem with the latitude difference, constantly expanding the further south you get. Where on a globe, if you were on a ball, your lines of latitude, yes, they are the same distance in between each other, but the size of the rings themselves, as you go from the pole down to the equator, progressively get larger on a globe. And then once you hit that equator, you're going to progressively start getting smaller, you know, until you get to the South Pole. Well, on the Gleason map, it just keeps on getting progressively bigger and bigger and bigger until that outer ring, you know, once you're 80 degrees south, you have a circle that's unbelievably, it's already 5 times too big than what a globe can actually account for. So we have that problem the Gleason has to deal with.
All right. Laurie, Thomas, can I just throw you to a curveball now?
Sure, sure.
Laurie?
Mm-hmm.
Can you hear me?
Yep.
Okay. I know I keep going on about this, but my degree went down in his submarine and he found this barrier to a lake beneath the ocean.
Ah, yeah, I've seen that.
Beneath the ocean, there would be fish. We could not catch these fish because there's this supernatural barrier of some sort. The submarine wouldn't. He said it was super saline, but we know that if you mix strong salt water with weak salt water, it just equalizes out. So I'm not buying that. I think there is some supernatural barrier to separate this lake or this ocean beneath the ocean. So if somebody was to catch a fish in the lake beneath the ocean, where would the fisherman be who was catching that fish? Where would he be? We can't catch it because we can't go into it, but somebody could catch that fish and have it for their lunch, couldn't they?
Well, they would have to be on the south. Yeah, they have to be on the South Pole side, I guess, up on the reverse side.
They would have to be on the flip side.
Yeah.
You're talking about the upside down world.
Yeah.
Yeah, no, let me just show you something, because I was looking into actually how. Let me do another.
I mean,
screen.
we don't know the depth, do we? Is there data on the depth that Mike Degree was in this mini sub that he hit this, you know, super saline, unpenetrable water? But we know that we can't drill. We do know that we can't drill deeper than 8 miles, or no one's been able to. No one's been able to have the equipment or the bit to drill deeper than, what is it, the Kola deep hole or whatever in Russia. And so that's 8 miles down there. We don't know that that barrier, whatever it is equally 8 miles down everywhere, both in the water and on the land. But something prevents us from penetrating below a certain depth.
Well, that could be just a simple matter of an extra chemical compound added to the H2 already that's there. Well, actually, it's a saltwater compound, but there could be something as simple as one more element added into that, you know, that chemical structure that changes it to the point it gives it a whole different effect.
Okay, so how is that any different than the barrier above us? If there's a barrier above us that people refer to as the dome or the firmament or whatever.
Well, something's got to be holding in the pressure. So, I mean, there has to be something there to hold that air pressure. As for a dome, yes, scripture does indicate that there's something solid there.
Okay. Can I just go into my curveball a bit more here?
Okay.
So when they manufacture a globe, they use two pieces of paper. This is a picture of one side of the globe, and that's folded onto a mold type thing to make that would be the bottom half, and then they've got another one for the northern hemisphere. So doing it that way, it would be a lot easier to actually fold a flat map onto a globe if you've got two flat maps, one from the top and one for the bottom. And what these two halves would be wouldn't necessarily need to be that. It could possibly be, say, one that goes to the international date line and one that covers the other half that's not the international date line. And what you would have there would be two halves of the Earth, and you could have one on the top and one on the bottom. And there is, funnily enough, there is a Collignon version, which is the two-sided one, which looks like this. And with this one, the continents are more regularized to what you would normally think they would be. So one of these would be on the back and one of them on the front. And obviously, wherever the join is, this would be the hidden line that where it reversed back onto the other side. I'm just throwing this out here because we know we're in a supernatural world, but we don't know the exact nature of it, and we need to look at other possibilities as to what it could be. And you know, the Mike degree thing for me is that there is an ocean beneath the ocean, and that if you could actually get into that ocean and surface, you're not going to be surfacing. You're either going to be surfacing in another world, or you're going to be surfacing on the other side of the Earth. You know, on a back-to-back map.
I get your flip side thing. It's a very interesting concept, but most people are going to immediately, you know, disregard it out of hand and say, you know, we never know. We've never felt that we flip over when we get to a certain place, and then we're all of a sudden, you know, on the backside.
Why would the creator build an Earth which had got an ocean beneath an ocean? And
well, I mean, that's literally in Scripture, Lawrence. I don't know if you're aware, but that is in Scripture, that the waters above and the waters below, that it says that above the firmament there is water, and below the earth there is water. And there is old scripture that, and I think it's non-canonical, that says, was trying to say non-canonical, right? And then I forgot my point. That says, back in the flood days, that prior to the flood, it had never rained from the heavens before. The water had always come up from below. And that there are those who believe that it actually rained from the heavens from below, not above, that it came out like from below and came back down. So this is the part where
primary water was called.
Primary water. When you start to get to what it is defined as the supernatural, supernatural just means it is undefined by man's natural laws.
Right.
It means we don't have an explanation for it. Okay. It's interesting that people poo-poo supernatural, but yet they believe they have their prayers answered. And that would have to have a supernatural effect, because no one's ever seen anyone's prayers answered. They've only seen the effect of their prayers being answered, like healings and things like that. Okay. And so you know me, I never have a problem talking about, you know, speculation and letting my mind go way outside the box and think very abstractly instead of concretely. So I don't have any issues with that. But when you start to use words like Pac-Man and 4D and that kind of explanation, it's because we don't have a science for it. We don't have words for it. We don't have defined parameters for what supernatural even means. People believe in the biblical story of, you know, the Hebrews going out into the desert and manna falling from the sky and them being fed. Well, where'd that come from? And so there's going to be two schools automatically. There's going to be the one who's going to define it in a natural sense, the best they can, and then those who are going to say it's supernatural. So, you know, how did Jesus take a couple of fish and feed thousands of people, and loaves of bread and wine from water and all that? They're readily capable of understanding that is supernatural, above man's natural law. But yet, if you say Pac-Man, they're just like, the record scratch sound happens and they, no, can't go there. So
yeah, I know. You look at the international date line and it's like a dotted line, isn't it?
mm-hmm.
If you can imagine, let's just imagine for a minute that there were two sides to the earth. When it hits the because when you look at time and day, it doesn't, as Jeremy and David Weiss keep talking about the sun morphing and going, you know, and teleporting, it doesn't, because the time and day sun distribution, once it's gone off one side, it's on both sides. So, you know, it's never,
mm-hmm.
you know,
never
once
completely
it gets
off
over
the map.
the edge, it's coming up on the other side, but it's still on this side.
Mm-hmm.
Now, if there was a flip side and the sun was, you know, coming back on the other side, then it would be shining on the other side automatically, which would be where it would be if it folded over there. I'm just wondering why they've got
all
that
right.
funny
Well,
line.
I mean, I'm okay with throwing these things out there, because we threw out some weird stuff a couple of years ago, and now people are going, hey, you know what? It turns out that was right. Okay. So we started saying the AE map and model was wrong 2.5 years ago, and we were slammed for it. And now all these people are coming on board and saying, you know, did you know the AE map and model is completely wrong, and here's why? And you know, it's not like we're going ho hum. Yeah, you think? I mean, we already know this. We're glad that they're seeing it also. It's, you know, I won't even go so far as to say, oh, I'm glad to see you're figuring it out. That's not the point.
Yeah, but this international
the truth is the truth, and it isn't about how many people believe it or not. The whole world could believe in something and it still be false. We all know that. The whole world believes we live on a globe, except for those of us who don't. And so in our minds, we don't know exactly what it is, and we're trying to define it. You can call it research, you can call it investigation, you can call it curiosity, however you want to label it. Once I figured out that it's not this, then what is it? Okay, which is a natural progression. It's the same thing that happened to people when they said, well, if it's not a globe, what is it? And there were those who were ready with their model and their map to say, well, here's what it is, and here's how it works, and here's our explanation. And they went, oh, okay, sounds good to me. So, and then they stopped. And then they
Laurie,
stopped.
let's imagine, I want you to imagine that you're the creator, okay? And you've created this place for us to live on. Well, you would never make it a globe because people couldn't stand up on it.
Right.
And you're going to have a two-sided world, all self-contained. Where would you put the scene? You would probably put it where there was hardly any land. You'd put it in the ocean, wouldn't you?
Yeah. Well, yes. Okay. But here's my first issue with it, Lawrence. And, you know, we'll continue to visit this over time. But my first issue with it is who's got the gravity? Because if you can't stand up on a globe from the bottom side, then how are those people on the flip side standing up? And both people on both sides, there's got to be something holding them together. So this is my first
but it's a realm, isn't it?
Pushback. Well, okay. but this is my first pushback to the flip side thing. And, you know, there may be something to it, but I would call that a parallel world and not part of the realm that we're in. That's my first thing about that. But Thomas hit on me with one earlier today about the one about the
mouse tracker ball.
The mouse tracker ball. Yeah. If we're all in our own world and our own realm, then perhaps we're on a mouse and we have a tracker ball underneath of us, and as we move, we're kind of like a little cursor moving around on the plane. I find everything like that something that my imagination can work with, and I can kind of, progress through it and find the problems and find the solutions and whatever. So Thomas, what do you think? What's your first response to the flip side thing of that being how it works? Because that's kind of anti-Enochian, and a lot of people are all about that as far as the ends of the earth have doors and gates and so on.
Well, it's understanding what these portals are is really the key to it. We're thinking that a portal has to be something that occupies space and time, but we're not understanding what the fabric of creation actually is.
Mm-hmm.
These portals actually don't have to take up any width or area whatsoever. In fact, they don't. And yeah, we were having a discussion earlier, and it was actually, I have two ideas. Because again, it's like you said, when people say, okay, well, if the AE is not the right map, then what is? And then the first thing I got to point out is, well, according to this UTM, all airports, military bases, FedEx, United States Postal Services, shipping docks, everyone's using a grid style UTM, basically. This continental structure, basically. And this is working. And here's the thing, they say, well, okay, if the United States is on the very western edge and I'm sailing off of California, I don't have a problem if I'm navigating with a UTM map and I look at my map. If I'm sailing from, say, California off the edge of the map and suddenly I'm, because I'm going to Japan, let's say,
Mm-hmm.
which is on the other side of the map, well, I don't have a problem with moving my head from the western side of the map and say, okay, now my boat's located on the eastern side of the map. And I keep using that same square map, and I can navigate anywhere I want like that. I don't have a problem in my mind reading this map. It's just placing it in reality people have the problem with. So people say, okay, well, what is the replacement? And I'm not here to offer you a replacement. I'm here to debunk the Gleason for starters, and now I will share what my personal preference is and where my personal research has gone. And yes, it is a Pac-Man system. And people are going to say, well, if this UTM map works, if this grid style rectangular or diamond shape is, I prefer the diamond myself. But it's basically a layout that you'd see on any standard UTM map. That's the one I prefer. People are going to say, well, okay, how do you teleport out one side and teleport back in the other side? And I say, well, there's no such thing as teleport. Nothing teleport. That's insane thinking.
It just keeps repeating.
Right. It's just, imagine standing in space and watching a ball Earth spin. What would you see? You would see United States spin by, then you'd see this Pacific Ocean, then you'd see Japan, then China, then Europe, and then the Atlantic Ocean, and you'd be right back to America.
And poof, there would be the United States again. Exactly.
Right. There's no division point there. It just keeps cycling. Now,
okay, so that is how you describe it using the wallpaper effect. Okay.
That's the wallpaper effect.
The repeated pattern of the wallpaper, whether you go left down the rolled out wallpaper or right down the rolled out wallpaper, the pattern comes back again. And
Well, that's
so
the same thing as the
when they
mouse
say
one.
4D, okay, the same thing with the mouse and Pac-Man. In 4D, there is time and movement. Okay. 4D is probably not even the right word for it. We're just trying to come up with a way to describe what, you know, our thoughts and our thinking process. And,
Well,
you know,
there's
we
only
can keep making fun of it until we get the right definition, but we're going to continue to try to figure out how to define it until, you know, and get the right words.
Here's the thing, Lori. If you check all the international airports, the distances between one airport and another, you can verify the UTM layout. Basic layout is the correct layout. Once you realize a correct layout, how the sun works and all the other stuff, that just, you have no choice but to accept that.
Mm-hmm.
Because if the map lines up, it doesn't matter if you don't believe in a Pac-Man system. And
okay,
fact,
so let me say this, just because. Okay, Jaron and David, during the debate, when I put the picture up of the diamond, okay, now that is what is called a Collignon projection, and it is a projection of a globe on a diamond rather than a square. Okay, and on that projection, the lines of longitude follow the diamond, the one in the prime meridian's in the center, and it's a straight line. But as the other lines of longitude come down, they come out and they come to the equator, and then they go back down to the, you know, converge back down at the South Pole. That's obviously wrong. That obviously the lines of longitude are straight lines. They do not have a break at the equator. Would you agree with that? And Lawrence agrees with that.
yes.
But if you mix the two, if you put the UTM and use that grid system and put the diamond as its parameters,
Exactly.
okay, now Pac-Man is going across straight lines, and there is no sun, moon, stars, or whatever that goes north and south. They go back and forth between an area, between Cancer and Capricorn,
Tropics, yeah.
but they don't traverse north to south. Okay, so that whole like crooked line thing, ignore that. What we're looking for is the layout of the continents, the spatial difference between them, using triangulation, okay, distances between airports, distances, you know, between continents and major cities and so on. You can find those distances and lay those continents out in the proper perspective. That's why people don't like the Mercator, because things are distorted in order to make it square, right?
Right.
But they're not distorted very much if you put them on the diamond. They all fit. And there is a natural break line where, mysteriously, at the 180 line, right?
Yes.
The international date line. That's where Pac-Man happens, on the left side and the right side. That's the two sides of the diamond. Now, just take away the image of this on, you know, with lines, all these lines, because those lines don't actually exist. They're just a grid created by man to define areas.
Whether,
so
you know
take
what?
away all the lines, both the perimeter lines and the longitude and latitude lines, and just fit the continents in the proper place.
Right.
And they will turn into a diamond.
Now here, one thing, I'm just kind of throwing this out there. It's a strange idea, but I noticed when you brought up the idea, we know that the international date line goes through the Pacific Ocean, goes through Russia, between Russia and Alaska, and it comes straight down to the South Pole.
Mm-hmm.
Now, that's also in the Pacific Ocean, where you have a very strange phenomenon jumping off, where it's they call it where two oceans meet. where they have two completely different densities of water, of ocean water, that won't mix and mingle with each other. And you could just Google image search for our listeners where two oceans meet. And these are two completely different color oceans, and they don't mix at all. They'll bounce off each other. They don't mix. And I was wondering if that might have something to do with, because you got to ask yourself, why did the people who created the globe in the first place, why did they pick that mark as the international date line?
And why do they move it around every once in a while? Every so many years, you know, somebody says, oh, well, we want our time change to happen because we don't like being on the same time as Australia. We want to be on the same time as Hawaii or whatever. Okay. And then it becomes a political thing and an international, you know, decision, and they can arbitrarily move the line. Well, the other curiosity is the distance between Alaska and Russia at the IDL is 55 miles, right?
Right.
And it's the closest 55 miles to build a bridge that anybody could imagine to connect the continents of you know, the countries of Russia and the United States. People will say, well, they never did that because of blah, blah, the Cold War. Okay. Well, we haven't had the Cold War in quite some time, and we do have international trade, and we do trade with Russia. As a matter of fact, we traded them, gave them one of those little islands up in there, but a few years ago. The point is have you ever done any research on why this bridge has never been built, and that they actually started talking about it a few years ago? And do you know what the cost is? I mean, it's astronomical. It's in the billions and billions, and nobody wants to foot the bill, they say. So
that's where
what if that 55 miles cannot be connected except by water or flight? What if it physically on land can't be connected? That's a question I have. I know it sounds bizarre. You know, they say, well, you know, the water and the ocean tides and the freezing temperatures and all these reasons. Okay. Mankind has built some pretty stupendous things. I mean, we've been to the moon back. So why can't we build a 55-mile bridge?
About these two oceans that don't mix, I mean, that defies all common science, does it not?
Sure.
Yeah, that's absolutely amazing right there, looking at that. I haven't seen that before.
That just sort of lends theories support to the possibility of two sides to a bloody coin. I mean, that is... How can two oceans not mix? They're both different colors, and it's not photoshopped.
Yeah,
no, it's not photoshopped. No, it's real.
It's truly.
Well, what happens if you go swimming there? You know,
I have seen not jet skis, people water skiing, and I think I've seen them go across that in water. There's water skiing pictures out there, I think.
Well, you know, they go across it in boats. I mean, there's no question about that.
Yeah, so it's not like there's any barrier there or anything. It's just the water doesn't meet, because I think it's actually two parts of the world. I think it's the western part of the world and the eastern part of the world, maybe, where the timeline is actually, time space is actually.
It's the repeat connecting. In the wallpaper. How about that?
Right, exactly. It's the tape on the back of the back of the ring or the loop. But you know what? Going back,
it's the joining. It's the seam.
It's the seam. Okay, it's the seam of the wallpaper stitched together. Yeah, okay, that's possible. I mean, you know, until we can come up with a language that describes what we're talking about, and be able to you know, use defined words that people universally will understand, then until then it's stupid things like Pac-Man and Jaron kept saying morphing. I don't have a problem with that.
Well, actually, the way I actually think it goes, if you really want to get into the technical aspects of, how Pac-Man actually goes. I came up with two concepts. One we discussed earlier, which was the mouse tracking ball system. And just to review that real quick before I go into the complicated one, which is probably how it actually does work. The whole mouse tracker ball, for our listeners, what this concept was is that imagine a mouse, a computer mouse that plugs into your computer tower on your desk. Now imagine yourself inside of the mouse casing itself. But this is an old mouse. Instead of having a laser light, it's actually one of them old ball tracker. It's got an old tracker ball in it. And you are constantly standing at the top of the ball. No matter what you do and no matter where you go in life, run as fast as you can, any direction, you will always be on the top dead center of that ball. What you see inside the mouse casing is, okay, here's that. The mouse ball that you're running on is actually, that's the server where everyone's PlayStation.
The rainbow again.
The rainbow.
Right. So all the information, all the data, everyone's PlayStation is attached to the tracker ball. So when I run, the ball spins. I don't move inside the mouse. Inside the mouse casing stays, only the tracker moves under my feet when I run. And if I happen to run into your mouse cage area, and where our two mouse cases overlap, now we can interact with each other because now you're in with my field of experience. So the whole concept is the whole inside of the mouse case shifts by the direction you are running on your mouse tracker ball. So if I run to New York on the tracker ball, the inside of the mouse casing suddenly looks like I'm in New York. If I run to Africa, it suddenly looks like I'm in Africa. That's what's projected. Everything is a personal projection.
All right. So that's sort of along the line of simulation theory.
Right. That was the whole. That's where I was talking about the whole. That was something completely different. But
But you don't believe we live inside of a computer simulation?
No.
Okay.
I do believe we live in an intelligent.
Good, because we went through all that already, and we already got.
Okay. Now here's my old theory, my original theory, and I'm still standing by this. And now this has to do with a lot of people are not understanding that this is an electric creation. Mm-hmm. Now people know that and they say that, but they don't actually understand what that means. They say, okay, well, this is an electric creation, but they still start picturing, gravitons and photons and muons and gluons and all kinds of atomic particles. Well, if you're still thinking that, then you're not understanding that this is an electrical creation. That's not. The universe is not made of these magic unicorn particles. There are atoms, mind you, but atoms are not little bags filled with these unicorn particles, these charged particles. My point is here's what's going on. Tesla discovered something. Well, actually, several electrical field theory people discovered it. But he kind of brought it to the forefront and gave us the real science of what was going on. It's something called the ether. And what the ether is it's basically what the physics guys like to call quantum fluid. This is completely incommensurable. It takes up absolutely no time. It takes up absolutely no space. It is always existing in a point of singularity. So like all of our souls, for instance, our spirit that connects all of our body, the spirit itself is pure ether. It is pure spirit. It is pure consciousness. But since ether can't take up any space whatsoever, your ether is connected to my ether, is connected to Lawrence's ether, connected to the ether that's in this desk. All ether is connected to a singularity. Ether cannot take up space. That is a point to remember, because we're going to explain why the sun teleports. Now, remember that point, that ether is completely incommensurable. It takes up no space whatsoever. An example of this would be in a magnet. When you look at a magnet, you see perturbations in the ether. We call it magnetism. It's a discharge. It's a radiating out. But when you put a magnet under a microscope, you don't see anything different about it and then an ordinary non-magnetized metal bar. They look exactly alike. There's something that pervades this, that's not taking up any space whatsoever. You can take this magnet and affect your TV screen and change the colors on your on an old tube TV screen, what you're doing is you're moving, you're agitating the field that exists, is this ether field. The ether is all around us, but remember, ether takes up no space. So here's the thing: we have our diamond, Earth with the standard UTM layout. Now, all along the edges of the diamond, where does this flat Earth sit? It literally sits in the ether. That means all four edges of our diamond are literally ether. Well, the problem is ether cannot take up space. It has to shrink down to a point of singularity. That means the eastern edge, the entire two sides that make up the eastern edge and the two sides that make up the western edge, they literally have to fold in on themselves. So even though reality itself is flat, or I should say the Earth is flat, creation is flat, the ether itself is folding, because we know teleporting is not possible. We know the sun cannot go out the western side of the map, and it cannot magically teleport to the eastern side. If it can't teleport, there's only one other option. The two sides are connected. Well, if the Earth is flat, but yet the two sides are connected, what's happening? Obviously, there's a folding going on. Something is bending, but we know the horizon is perfectly flat. It doesn't fold on the edges. It goes perfectly straight all the way out. So there is no... Right. Now, if we were living inside of a concave ball, the sides would curve up. If we were living on a ball Earth, the sides would curve down. But we see the horizon line is always eye level, no matter how high you go, and it's always a perfectly straight line. So we know we live on a perfectly flat, stationary, intelligently designed system. We know this. We know that the UTM map style works within the diamond perfectly. We know that when the sun takes off outside the left wall or outside the western wall, it comes back in the eastern wall. However, it doesn't teleport. Nothing teleports. It's a seamless connection because the eastern side, excuse me, and the western sides are folded in together. This is where they originally got the idea of the ball Earth. When Einstein got out there and tried to say, Einstein made a correct observation, but and drew an incorrect conclusion. He saw this problem. He realized what was going on. He said, well, space must bend. And this is caused by the weight of the Earth, and this is what gives us our gravitational pull and all this nonsense. Well, here's the thing. It's a correct observation. It's just an incorrect conclusion. Space isn't bending because you can't bend space. That'd be like trying to bend a shadow. You know, a space is a lack of something. It's a lack of charge. Ether is a state of charge. Space is a state of discharge. When ether discharges, it radiates out as magnetism. This constant expansion of magnetism, the magnitude, creates space. The measure of the magnitude creates time. Time is not a force, it's only a measurement. So that's what I'm saying is that Earth is flat, it's a diamond shaped, it's UTM shaped, or the continental layout is UTM. The sides literally fold in to form. If you were to step outside of reality and just step into the ether and look at the Earth, I believe you would see a ball. I believe you would see a concave Earth. I literally think you would see that. But if you step inside of the reality, it's a perfectly flat plane. But I'm saying, so you have to determine, okay, well, if the sides are folding, which way do they fold? Do the sides fold under, you know, so that we live on the outside of this sphere, or do they fold upward? And according to the Mason's information, it folds upward. And it would actually be, theoretically speaking, concave. Concave Earth would actually, you can see where they get the idea, because they just literally took that flat Earth, folded it up through the ether, except the concave Earthers can't explain why, you know, why it folds up.
Flat.
Right. And they can't explain. They're trying to say magnetism is holding the water to the top of the inside of the ball. Well, that's absolutely impossible. You can't make water stick to the top of the inside of a ball any more than you can make water stick to the outside of a ball. However, if reality is flat in your mirror, or creation is flat, but reality is curved in on itself so that all sides meet to form that point of singularity that ether must be, then there's a seamless connection. There's no loss of time. There's no loss of space. You don't notice anything. You just keep going. You're literally in a flat, concave Earth. Both are true.
When when Lawrence and I first started talking about the IDL, and is that where the end of the Earth is, where it starts over again, the seam in the wallpaper, so on and so forth. And I imagined an experiment where you had 3 ships and they were staggered, you know, one up there, one in the middle, and one back there. They were all in sight of each other. And they approached the international date line, where suddenly it's tomorrow when you go over it, which is just a measurement of time. And to test this theory, of course, you know, I had it in my head, one of 2 things is going to happen. As ship 1 goes over the date line, can ship 2 and 3 still see it? Can ship 1 still look back and see 2 and 3? Well, of course they would. Okay. And then if they kept progressing and ship 2 went over the IDL, and 1 and 2 can now see each other, but they can't see 3, and 3 can't see 1 and 2. But you know that there's shipping lines that go across the Pacific Ocean, the IDL, all the time. And those shipping lines are close. People stay within certain parameters with these ships for all kinds of reasons, piracy being one of the most important, and not getting lost. And of course, you know, being in, probably there's a reason why they go a little bit north or a little bit south, because of tides, currents, whatever. But it would be interesting, the same thing with the plane, you know, having 3 planes flying to the west or to the east, either way. Of course, they wouldn't disappear. They would just keep going, right? You're muted, Thomas.
Yeah, I was muted. Yeah, you're exactly right on that. Yeah, you don't just magically disappear. You don't magically teleport. It's just a continuous trek. It's the same way if you're standing in space and you're watching a ball Earth spin. It's a continuous trek. As the ball spins, imagine you're drawing out everything you see. You're just going to continue drawing out this big, long film strip, you know, just of repeating over and over and over. However, we know that only one of those frames is reality.
Right.
So again, if nothing is teleporting and we know only one of those frames is reality, there's no other choice but reality itself has to bend. Even though we
Which is why we cannot time travel. We cannot time travel to the past.
Not to the
because
past,
it's already gone. And I don't think we can time travel into the future because we're not there yet. Now,
well,
possible.
Well,
of course, if you, it's that
I got some
conundrum.
ideas.
Time travel into the future, somebody in the past would know that you already did that, right?
Yeah. Well,
okay,
you would just be locking yourself out. All you do is you're literally would have to create with some bismuth and magnets. You would have to create your own magnetic field, completely separated from the Earth. So as the Earth's magnitude is increasing and moving out, you're literally being isolated. So you're not part of that. So time doesn't pass for you, but it's still going forward. And when you came out of your bubble, you would conceivably be in the future. But again, it's just you're
but you
kind
could
of
never go back. If you went into the future, you
No.
can never come back. Okay.
No, all you can do is create a bubble and let the Earth's natural magnetic field travel past you while you stay isolated. So time conceivably doesn't pass for you inside the bubble, but it passed for the rest of the world outside the bubble.
Well, you know, the creator would be smart enough to go, you know, these silly humans one day will want to travel into the past or the future. So we have to put a preventative method in there for that not to happen, because we already know what the ramifications and consequences of that would be if they did that. So, because they would be able to change the past or the future.
And you know, it's kind of interesting. You know, remember when we talked earlier, I says type in world maps and don't nothing Pacific, just world map, and you'll get all these Pac-Man Earths. Well, and I said you won't see a Gleason, but another map that's very common pops up on these searches is a concave Earth, and you'll know it. It's a concave Earth model because it's two halves of the Earth. But look at the lines, your longitude and latitude lines. These are actually concave Earth maps.
Mm-hmm.
And I believe absolutely that is why they drew those concave maps, because they knew the continental layout was like our rectangle UTM or our diamond UTM. They knew that was the correct layout. But how do you explain? That's what I'm telling you. That's how they got it. And when you bend it the other way, you get a globe. And they said, well, we got to make a decision. Let's go with the ball, because the ball says that we got unlimited outer space, whereas concave Earth says there is no space.
Well, you know, before that, they did have the, you know, the sphere. They had the fixed plane concave Earth, and then the celestial sphere around it. Remember that?
Well,
Those maps.
I'll tell you what. I'm not promoting the concave Earth in any way, shape, or form. Don't misunderstand people.
Neither am I, and I'm like a little weirded out that we're even talking about it, because somebody's going to go, you know, those idiots, they were talking about the concave Earth.
No, but, however, just like you know, even though I disagree with Jaron, I gave him props on that whole personal dome idea when I came up with my mouse tracker ball idea. I got that from him. Well, I'm gonna give props also to another guy I don't really like, and that's Lord Stephen Christ. He calls himself. That's what his YouTube channel is. He's pretty much the king of the whole concave Earth thing. And I'll tell you what. Yes, the Earth is flat. No, the Earth is not concave. But if you go with the theory that I just expressed, that our flat Earth is literally the reality itself, the ether itself is going to fold in on itself to form that singularity. It's literally going to form a concave ball. Even though we see a flat Earth, it's a concave ball in the ether. And by ether standards, Stephen's diagram or his model of how the center works, forget his concave ball. That the water can't stick to the inside of the ball. That's garbage. But look at the center, his center model. He's got this black star sphere that's where all the stars are actually in the sphere, and then he's got the sun and the moon attached to this. He's got the rotations perfectly explained, the planetary movements. He's got them all. His sky is flawless. I'll give him that. Now take his sky and unfold it from a ball and make it into a rectangle or a diamond, and you've got reality as we know it. His sky is that perfect.
One of the reasons why people like Neil deGrasse Tyson say you can't get far enough away from the Earth to see that it's a ball, right? You can't get far enough away to see the curvature.
Right, and you can't, because you would have to be in the ether. Right, you would literally have to be in the ether.
And then there's those people who believe the circle model because of, you know, Picard, who went up in the little, you know, bubble ball thing with the balloon and said, I saw an, you know, Earth with a circle Earth with an upturned edge, right? Well, of course it looks like that from that far up, because you're seeing the atmosphere at the edge, because that's where your line of convergence would be by eyesight.
Right.
But you're not seeing it the same way straight down. He wasn't able to really look straight down. He's looking out. Okay. So it would, I think it would look like that, because you would go up, you would go sky and, you know, land to sky to blackness. And that would be where everything's converging together. So I'm not surprised that's what he saw. But I don't at all take that as that we live on a circle, because people want to equate the upturned edge as what? The ice wall.
Yeah, I'm thinking that upturned edge is just that he was at a height, because everything is rising up. Everything below your eyes rising up and everything above your eye is sinking down to your eye level. And I think he's looking through a curved glass because he was in some kind of circular bathysphere.
Mm-hmm.
And I believe this is a
Yeah,
curved
it was a
glass.
sphere.
Yeah, and plus you got a curved glass he's looking through, and it's the limit of his sight, what he's able to see. It probably did appear to be upturned because of the glass he was looking through, most likely. That's how I would think.
Well,
Because
if you've ever been on a really tall skyscraper on the roof where you could literally stand there and turn your body 360 degrees, it looks like a circle around you because that's your circle of sight.
Right, exactly.
It does look circular. It's a huge freaking circle when you're standing that high. I mean, I was just on like 16 floors looking at Sarasota, Florida is really flat. and I was, it's down by the water, so I could see the ocean and, and then the land and back to the ocean. And sure enough, Lawrence's computer just went down and back to and it does look like a giant circle because that's how far you can see in all directions. Your eyes are going to make a circle.
Right. That's always, it's always going to be a circle because your eyes can see a specific distance. Mm-hmm. If the human eye is not unlimited, it's not Superman. You cannot stand on New York and see all the way over to England just because the earth is flat. Your eyes just can't see that far. Neither can cameras. That's why, one camera can see out a mile or two, but another camera can see 10 miles. And then you can get out a telescope that can see 100 miles. You can get a periscope. The periscopes on them submarines, the military subs are, those things pop out like 1.5 to 2 foot up out of the water, and they're able to see 120 miles away.
That's
amazing. That's not possible on a ball.
On a curve, on a ball.
Yeah,
no.
That's utterly not possible that they can see something 120 miles away. So yeah, I mean, this is
all right. So let's start to have some closing statements and wrap this up. So we keep it up pretty close to 3 hours, and then we're going to do this again tomorrow so that we can extrapolate on even some more proofs and other interesting new information that we didn't put out tonight. Lawrence, can you still hear? I see that you're muted. All right. He'll figure it out. He always does. So Thomas, do you have anything you want to, kind of that circular thinking thing where you started to come back to or anything like that?
Well, what else do I have that I wanted to go over here? Honestly, that pretty much tracker ball, concave Earth, explain magnets and ether. Well, we'll have to do the magnets and ether on another point and do that on a break. Oh, here's a point that we didn't cover tonight. Just as you say, a pilot flying the equator on a ball would constantly have to dip his nose down. A pilot flying the equator on the Gleason map would constantly be turning. And this would be obvious because the rudder on the back of the plane is going to turn left or right if the plane's in a turning. So it's not a matter of, well, the turn's so, small and insignificant, you don't notice it's turning. Well, that's the same nonsense the ballers tell me when they say, well, you don't notice the curve of the earth, so no, the pilot doesn't have to dip his nose down. But we've already done the math on that. We know how many feet they can travel before their nose has to dip down on a ball. That same exact math applies to the Gleason map also. If you're flying the equator, you're constantly turning. The rudder is going to be visibly turned, if you're following that equator.
Banking, right.
Yeah, so there's going to be no question about your turning. It's not going to be, well, the pilot just doesn't know and the GPS is secretly doing like there's some big conspiracy here. Right. That's not how it works.
Pilots know what's going on, whether it's being flown by autopilot or not. They still are aware of the gauges and so on.
Oh yeah.
Because would you, as a pilot, 100% depend on autopilot
Oh, absolutely not.
Never have any glitches with computers, never any bad code, never any bad programming. Nobody could ever hack in. Nobody could ever have distorted the code before that. You know what I'm saying? You would always want to double check and keep your eye on what's on the gauges and what's going on in the cockpit. So, all right, Lawrence, do you want to wrap up? He's having problems again. Okay, so what I would like to say is, first of all, there were several people who were unhappy with me saying that I was arrogant to Jaron and David when we were doing the debate, and that I talked over him and so on and so forth. And if anybody thinks that I was being rude or arrogant, my apologies to you, because if you're in the heat of having that kind of discussion with 4 people, with no moderator, with new technology that I had not used before, one of it was OBS Studio, which is an app that you had to do all this streaming through. The other was Skype, which I was not, had not done a hangout with Skype before. So I was a little bit scattered that. Okay. And second of all, my apologies for my voice. If you don't like my voice, my actual voice has been the same voice all my life. I never took voice lessons. I could talk like Minnie Mouse if that would be better, or Chippy the Chipmunk. But I think it's more about, if you don't like the information that you are hearing, you actually decide you don't like the voice or the person delivering the information. So that might be something that you might want to study about yourself, because I really don't have a, scratchy fingernail on the chalkboard voice. So I just wanted to say that, because I really would be interested in a study of people's voices delivering information that you want to hear, and the same voice delivering information that you don't want to hear, and whether or not you like the voice any better or worse, depending on what it is they're actually saying. So there's that. The second thing is, I had a nice time on the debate, and I think everybody acted very, very nice and cordial. And I don't think any of us walked away from it being, pissed off at each other or feeling mistreated or maltreated. So I think there should be more of that in the future, of people openly discussing their pros and cons to flat earth information. And instead of hiding behind dogma and mythology, is if someone can actually show you evidence of something that goes against your whole preconceived idea about the flat earth in the world. We all have one. Every single one of us has a different take on flat earth. So, Lawrence, you keep coming back, but you keep coming back muted. So maybe you need to figure out what's wrong with the audio instead of the camera, because that's like the 83rd time he's tried to get out and come back. Okay, so I was hoping that he could have some final words, but and say something, but it's possible he won't. So we're going to be back tomorrow night, November 18th, at the same time, 6 p.m. I don't know how long we'll go, but we'll just openly discuss what comes about, and we'll put together some more points, each of us, to stress and talk about. And until then, I'm sorry, Lawrence. I know you're trying to get back in, but we're going to wrap. So thank you, Thomas. Thank you, Lawrence. And please visit Thomas's Facebook page called Flat Earth News, but only if you're not a Glober and if you're kind of over and past the AE circle concept, because he doesn't have a lot of patience for that argument anymore, and neither do I. And we'll see you tomorrow night. Thanks, everybody in the chat. Thanks, everybody, for viewing. And Lawrence just sent me a message. Nothing works. So we'll try again, and hopefully he'll get it worked out for tomorrow night. So good night. Good night, Thomas.
Good night.